Hello and welcome to this training video for Impact Revit. So in this video, we'll cover the whole Impact Revit training material. So it will be detailed and a little bit longer, but you can of course divide it into several sessions. I'll cover the material or go through the material as if I were a normal user gonna learn Impact Revit. So I hope that you want to follow along here. The first step is to find the material, and it's all on our wiki page. So it's wiki.impact.strusoft.com. And this is how it looks. I will zoom in a little bit so that we can see clearer. If you scroll down a little bit, and on the left side here, we have courses, and then we can click Impact Revit. And this is the course material that we're gonna do. Um, we have the model, so this is also something that we will, it will look like this when we are done as well, and some table of content of the chapters. So before we continue, I just wanted to make sure that we are all on the same level here. So if you are a user that is looking for a trial of Impact Revit, so you don't use Impact for any Impact products right now, then if you haven't got uh, some material to set up both the applications but also connect to our trial database, if you don't have got that from us, just contact any of the salespersons and we'll be happy to help you. If you are a current user of any of our other applications and you have your own server, then make sure that you have got the the um, the Impact for Revit standard from us at Strusoft. If not, then pause the video here and contact Strusoft, and we'll give you the standard. And the reason for this is that, yeah, if you are a someone that doesn't have Impact Revit, then of course you cannot continue with the material without having the application. If you have your own database and your own standard, that one is not prepared for using with Revit, so you will miss a lot of things and it will not be a pleasant journey. So with that said, I hope that we are all on track. So we have everything connected, we have everything installed. So then the next step is to start with the training. So we'll click this button and we'll come to an introduction, and it's 2 pages of information of first how Impact works with Revit, and then how how the views in Revit works. So I won't go through these 2 pages, but just hit pause on the video and go through them yourself, because you don't need to like understand everything from start, but if you just have read through it and looked at the pictures, then you'll have a huge advantage when we continue the training. So I'll click on this button, and we'll continue with the actual project. So in our case, we are gonna use a project export, which is a project that I've prepared, and it's prepared with some references and some definitions for different things, configurations, let's say. Um, so that's what we are gonna do. But in reality, in a normal case, you would not do it that way, but you would use this new project process or way. Uh, this is not included in the course, but I will just talk a little bit about it so that you know how that works when we are done with the first training project. So first of all, I need to start my impact project manager. I already have it started, but if I wouldn't, I'll just start it here. And this is how it looks like. So if I would like to start a new project, I'll click new and new here again. And then it will work for a second and it will pop up this dialog box. So it's a lot of things here, as you can see, things that we can change. But the only thing that we need to focus on is this general page. And most things can be added or modified afterwards after we have created a project. But there are two things that are really, really important that we get from start. And that's the common and local here, like what standard we are gonna work in. So now if I wouldn't change this and my aim is to work in Revit, then I would not have access to all the Revit files that I need for the project. So this is the first thing, to make sure that we have the correct standard, first both common and local level. So I only have one local, so that's fine. And then the second important thing is that the project number here, it's called only project, but it's usually the project number. That also needs to be correct and no mistakes in it. Why is this important? Because these two are used when we are creating the project, both in the database but also in the folders that we have on our PC. And if any of these are wrong, then it won't work in the when we start drawing. So if you do any mistake here, then the only way to undo it is to delete the project and create a new one. So just make sure that this is these two areas here are correct. Then like title, description, project manager, and project color or whatever here, that can always be done or changed afterwards, but the project number and the standard is not something that we can change afterwards. So everything like I said here is described in this first part. So it's just information. But we are gonna import the project, and the project is available here on the wiki. So we'll just hit click here to download, and I'll just save this one. So I'm doing this in Impact 17.1. We also have it prepared for 17.2, and yeah, the just make sure to download the correct version, basically. So now we have that downloaded, so I can go back to my project manager, and I'll close this new project dialog, and instead go to this import. And I'll make sure that I go to the project here and click on these three dots. Then I'll find my file. So this is the file that I'm gonna use, and hey, say open. So we see first of all that it's a zipped folder, or yeah, I said file before, but it's a folder. So it's zipped. This is also what we need. If you unzip it and select the unzipped folder, you'll get some warnings that you have selected the wrong file format or so. So make sure that you just download it and then you don't need to do anything. Then we have some information about the source standard, what standard the original project was made in, what the name of the original project, who exported it, and the date. Then we have the target, so the target standard, and it will, if the standard exists on both places, then it will just match. Otherwise, it might be empty or it might be another one. If that's the case, then you don't have the correct standard. Then pause the video, contact Microsoft, and we'll help you. Then we have the target project, and it's the same as the source. But I want to be able to find my projects later on. So I'll add my initials. so just afterwards. And we'll also get a warning here saying that the target projects differ from the source project, the name of it. And that's by purpose, so we can just ignore it. One thing again here, or more, is that if I would use a space, then we'll get this red border and it says invalid project name. So we cannot use space, so we need to have an underscore instead. Then normally this one here is unchecked, so I'll just check it so that it will open the project after importing. Otherwise, I need to go and open. So I'll just hit import. And now it creates the project in the database as well as it creates a folder structure in our on our PC. And now when we are done, we can show log, but we can skip that one. So now it opens. So this is the project that we're gonna work on. It's empty with the elements, but there are some things prepared. And before we continue with the project, I just want to show you how to do this if you were, let's say that you are, it's the day after you started and you want to continue where you left off. Then you start the Impact Project Manager again. And then in the start here, you can probably find your project, or you hit open and find the begin Revit and your initials and just open it from there. So either it's in here in the recent, or you can, if you don't find it here, you can go to open and find it, just so that you have the info. So the next part, if we go to the material, so we have imported, and the next part is to add floors. But for our project, it's prepared with the floors, so we can just have a quick look at it. So we find it by here in the project browser, right-clicking on model, and then buildings and floors. And we can see that we have three floors set up with different elevations and so on. And we have some parameters here showing different, or is used for different things basically. So A is for the elevation, for instance. E is the floor to ceiling. D is the floor to top of opening, and so on. So all of these is connected. And if I make this a little bit bigger, I'll also show you that this is a dynamic one. So let's say that I would create a fourth floor or a first floor for another building, let's say. Then I right click and say new, or use this plus symbol, new. Then let's say that it's going to be called building 2. It's going to be floor 1. And you see that now we got the next elevation here. So we take the previous elevation and add the floor or story height. But this one should be 0. And you see here that it's 7,800. If I change to 0, there, you will see that it updates. Also, if I would say that C here, the story height should be 3 meters, then I can just remove. It will be red here because the ceiling height is lower than the floor to ceiling, but it's just temporary. And if I put 3 meters, it will update. So it will be a bigger gap here. So this is where you create all the floors and buildings. So I'll delete the one so that we don't get the project messed up. But anyways, if you're gonna start from scratch, like creating a new project, this is where you start with building up the levels. So I can just cancel, and the next step is to open the Revit model and start working. And this is also done here in the project manager. So the project manager is basically the center hub of impact. So even if you're working with design for Revit or AutoCAD, or if you're a project manager, you work in the production or anything, then you will all work in this application. But we're gonna go here and on project files, yeah. If you expand that, you have Revit, double click, and you'll find the model. So select it and hit open. And now Impact will start the Revit application, so it will take some seconds. And while we wait here, I just want to highlight that if for some reason you had the Revit open when you imported this project, then you need to close it because, yeah, it's a little bit technical, but we are storing or we are reading things from the database while opening Revit. And if we have this the Revit open while creating a new project, Revit or Impact Revit won't know that um, yeah, the project exists in Impact. So that's the reason. So you don't need to think about this at all. Just yeah, have in mind that if you had Revit started from yeah, while importing, just close Revit and open the model here again with open, and everything will be fine. So it will be done here soon. There it is. It's just hiding behind my project manager. So yeah, this is the project. This is the cover page, which can be customized. But I can click here on the default 3D view, the little house on top, or here in the project browser. I also have the 3D views. So this one with the parentheses is the default one. So this is what we get. So we see here that we get the same floors generated in our model from the project manager. And the next thing we're going to do is to take a look at yeah, the preparation we will do in the model, which is adding grid lines. So I'll go here to level 1, and we can see that we have a reference here. This is one of the things that is prepared in the course project. So from here, we're also going to add the grid lines, but we can see that we don't have a reference where to place the grid lines. So we're going to start that, and you do that by going to Insert and then Link CAD. And then we need to find the course folder, and the easiest way is to go to the project manager, and then on drawings, select and right click, select the open folder, and you'll get the folder, the project folder like this. Then if you click here, then you'll get the search path selected. You can go back to Revit, paste the search path in the file name, so just like this, and then hit enter. Because when we do that, we'll go into this folder, and then we can easily navigate. And our PDF or its DVG drawings, they are in common drawings, and we can find the system lines. So before we open, we just switch the import units from auto detect to millimeters, and then we can hit open. And now we get the grids. So that's great. And the next step for us is to yeah, add grids here. This is the things we just did to find this folder and so on. So the next thing to do is to start and draw the grid lines, and that's a Revit functionality. So we'll find that under structure and datum and grid. So just draw according to the reference. So from here to here, and we can see here that we get the number, the tag, the bubble as it calls, just on the right side of the grid. That's fine. We'll just continue and we'll fix that later. So just go through. So start with the horizontal ones and go from top to bottom so we get the correct numbering, like that. Then we do the vertical one for A. And when we click here, we can zoom in and see that it's saying 6, but it should be A. So just click on the 6, and then replace it with the A, and like this. Yeah, so write an A and say enter. Then we can continue. So with this one, and you see now that it will be B. So it will remember. And if you would misclick, so I would click here, but let's say that I click there, that's wrong. Then you can just escape once and then click again, because the command will, if you escape once, the command will still be active. So we'll just do like that and finish all the grid lines like that. And to get the bubble on both sides, we just select the grid, and then we have a checkbox on the side here. So just check it, and the grid will, or the bubble will appear. So just go through all the grid lines and do the same. Like this. So everything is prepared and we don't need the external reference anymore. So we'll go to and go and turn it off. And that we do in the visibility graphics. So either you do go to view here and visibility graphics, or use the shortcut VV on the keyboard. So 2 V's. So that's you will be here quite a lot when you are modeling. So that's a good thing to learn. So VV. Then we go to imported categories and then uncheck system lines and say OK, because then we don't see the reference anymore, but we see the grid lines. So the next step is to, or the last step is to save those grid lines to the database, and that we do through the Impact tab. And on the very left here, we have settings for the project. So we'll click down and say Manage Grid Lines. Then on the left side, we have our unlinked ones, and then on the right side, we have linked. So we'll just take one by one. And if you are working in 17.2, then you can select all at the same time, but that functionality is not available in 17.1. So we'll just take one by one, and we'll soon be done with all of them, and say apply. So now everything is okay. So we click close, and then we can go back to the begin, switch to model view, and up here we just click down and say reload model. Then we will get everything that is saved in the database. And we see that we get our grids. So now we are prepared with the model is prepared for us. So we'll go to the next step, which is the walls. So we can click this button. And the first thing to take a look at is the wall definitions. And a wall definition, or a definition in general, is a combination of Revit families and impact database information and also functionalities. So the definitions for walls is based on one system family, as it's called in Revit for walls, which is holding the information about geometry and materials, and some functionalities from impact, like adding automatic reinforcement, lifters, and so on. So to combine those, we have created something called definition. So we'll take a look at that now. So we'll go to the elements area. So that's wrong. Go to Revit. So here we have elements, and we have all the element types available. Or we have one, let's say one list here. We can see it like that for all element types that we have available. Then we can click down, and the second functionality or second command highlighted with a gear symbol is the definitions. So it's called walls. Then we're gonna take a look at the external walls. So it's gonna be sandwich, and select the SW34 and make sure that we are on project level. Then we click edit, and we'll get the definition. So on the left side here, it's more or less the only information we need to get the system family from Revit. So it's the layer structure, so outer panel, insulation and inner panel, the widths, as well as the materials. Then on the right side, we have impacting functionality. So first one is what side should be up or down in the mold. And this is, depending on what solution we pick, is we'll get either the inner side or the outside smooth. So the form side will be the smoothest one. So we have inner panel up or inner panel down as options. Then we have the production line setting, and it's a setting that allows you to, in your standard, configure what type of molds you have, and for the, in this case, walls. And then you will just enter information about width, length, and the maximum thickness that you can cast on the table, as well as the capacity in weight. So both what the table can handle, but also what the crane in the factory can handle. And with these parameters, Impact Revit can give you some warnings when and if you are exceeding either the production limits in size or in weight. Then we have the reinforcement template, which is automatically adding meshes, reinforcement around openings and around the outer geometry of the wall itself. And then we have the last one, which is layout. So this is a functionality for the drawing, how to rotate views if we have tall walls that cannot be casted or transported standing up, that we need to lay down, which we are calling rotation walls. We'll take a look at that just in a little bit. Then we have the lift and bracings area, where we set up lifts and bracings. So I'll actually switch to the course material here, because we have some pictures prepared. So this is what we already went through with the Dremel tab. And in the lift and bracings area, we have for lifters two different subsections, let's say, of settings. So we have the first one, which is controlling like what type of lift to insert, and then we have the lifting configuration of what components to use. And we'll get automatic lifts and also bracings, but we are focusing on lifts now in the element. But we have some rules to set up so that we can get what we want, basically. And the first thing here is to decide if you want one lifter, two lifters, or four lifters in pairs like this into the wall. And that you decide with these here. So you say set up like this, that yeah, minimum distance between two lifts. So this distance here, if that's less than 1500, then we'll insert 1. If it's more than 4000, then we'll insert 4 points. Then while inserting 4 points, the spacing here is 500 millimeters in my case. So that's the first factor or of the what lift we insert. And then the second one is the the lifts itself, what they can handle in mass, in tonnage. So you build up a list of the families to use and the cost material definitions and what they can handle, and then Impact will insert lifters according to both your setting up here. So this is if you want to use 1, 2, and 4 lifts in your walls. You can also configure it to only be 2 lifters in the walls by just setting this one to 0 and this one to a high number, basically. So these two works in combination, but then we have something called type, so the default type, and the types are here, and it's like you can use it in different ways. But let's say that you have the same lifter, the same component, but it can be used in with different lift angles. So with different lift angles, you will have different they can handle different capacities. So that's something. Then what you do is make the same setup again, but have like lift angle 60 and 45, let's say. Then what we use here is the one that will come automatically to the element. And then if you would in one project would switch, then you just go in here and switch on the projects. Then we have the default lift type, let's say like here, the default lift type other, and also lift side other. And the lift side other and default type other is the other lifts, that we call it. So let's say that we have this tall wall here with one lifter in the top. That one cannot be casted or not even transported like that. So we need to rotate it like this. But when we do that, we'll have we need to have lifters in the new top, which is the side of the element, and then these lifters are called other lifters. So we have a setting of what type to have there, if you want another type, let's say, or if you also which side to insert this in. So in this case, left. And then let's say that you won't have symmetric lifters, then you can rotate them one by one on both in the wall. So that's the setup. And then the for the lifters, the setup for the lifters. Then we also have automatic bracings, and it's a little bit easier because we only have one size of the bracing per wall definition. So this one here is going to be used in all walls with this definition, and we have the configuration for placing. So we have 3 different options for placing. So either we have it fixed distance from side, and this is then in the length direction, of course. So then you put the X distance here, and we'll have it always inserting that distance from edge. Then you have part of length, so then it will adjust the distance here according to the length. Or if you want it in center of gravity, then we'll just calculate that automatically. Then in the height direction, let's say the Y direction of the wall, we also have 2 options how to place the bracings. So either a fixed distance, the H here, or the part of height like this. So it will depend on the height. Then the last tab to go through is the naming, and here we can set up rules for naming. So if we start in the middle here with the prefix element mark, this is the prefix that we'll automatically get when trying to save elements. So we usually want to have different prefixes for different types of elements so we can keep them apart easily. So in my case, for sandwich walls, I'll have SW. Then we have something called, or we can start from top. We have group and products, and that's like two parameters that can be customized, or the use of them is customized. So this is like if you, let's say that we have two different wall definitions for SW34, so 340 millimeters. And the difference is that this one here has 120 in inner panel and 70 outer panel, but we have another called SW34-2, and that is 80 here and 110. So the total width is still 340, but it's just how the inner and outer panel are built up. Then this is very important for you as a designer, but it might not be that important for the people in the factory. So then you can put the product to be SW34, so the thickness. Then the people in the production can use this parameter to filter out the data instead of the definition like that. So that's just one example. This one can be used in different ways. And then the prefix designation is something that we use here in Sweden, so that we have uh, the prefix that the designation prefix and uh, the thickness and the height of the element in centimeters. So this is very, very specific. Then we have the prefix drawing. So if you would not have the same prefix or name for the drawing as for the element, so let's say the element is SW100, then if we have this one empty, the drawing will be named SW100. But if you want some other prefix like a number or so, you just put it here and we'll get the number for the drawing. The element in the drawing will still be connected, but they will have two different names. And then in the end, we have something called building information properties, which is, yeah, some things we can add to the IFC while exporting that. So this is the definition. A lot of information, and don't worry, you don't need to remember everything right now. It's all described here, so you can come back anytime. But instead of just listening, we'll start doing. So the next step is to draw some walls. So we can just close this with OK if we haven't changed something. And this is where we're gonna start. So we go back to this and say draw walls. And the first thing we're gonna do is prepare the view a little bit. And the reason for that is to yeah, keep track of what we are doing. And it's good, especially now in the beginning when we start learning Impact Revit. So we're gonna draw the walls on a plan drawing, but we're gonna have the 3D view next to it. And you do that by going here and just taking the 3D view and dragging it like this. And then when you are in the border here, you can just drop it and it will be on both. And we can see here that we also have this the same here, the references in this view. So as we remember from just a moment ago, we make sure that we are clicking here in the 3D so it's activated. Then we can go to View, Visibility Graphics, or VV. Imported categories and turn off the system lines. So this is the same procedure in each view. Then I want my I want my 3D to be a little bit smaller, so like that. And if it's like zoomed in or so, I can just double click the mouse wheel to center it. The same here, double click the mouse wheel and maybe zoom in a little bit. And now I'm prepared to start drawing the elements. So we'll start the command, and it will be found here in impact and then elements under walls here. So top is draw wall. So we'll select external wall sandwich, and current selection should be project, and then we have our SW34. And the direction that we draw this one in, or first of all, the um, the direction of the wall is depending on which panel it's up or down in the mold. So in this one, we have this rotation due to our setting. And yeah, as we see here, the arrow that I have added to this picture is the direction of the wall. So this one is the left side and this one is the right side. So with that said, we need to make sure that we are drawing the element in this direction. So let's say that, yeah, in this case, it's going to be like this, clockwise. And the reason for that is that we want the inner panel to end up on the inside of the building and not outside. If I would draw it counterclockwise, I'll have it like this, where the inner panel, the thicker panel, is on the outside of the building. We are looking at this corner now, just for your reference. So that's something that we want to avoid, because if we end up in this yeah, with this result, then we need to delete the walls and draw them again. So we'll do it clockwise, and we'll start command or continue starting the command, of course. So we'll hit OK. And if you have used Revit before, you recognize this modify place wall with the green and so on. So now we are taking advantage of Revit and selecting or using their settings. So first of all, we have settings for how to draw the wall according to the level 1 here. So we have depth or height. So it's like, okay, is level 1 going to be top of the element or bottom? So in my case, I want to draw from level 1 and up in the building, so it should be height. Then we have something called, yeah, it said unconnected, but it's like connecting the top, where how far should we draw up in the building. And the default is unconnected and 4 meters, but we want to draw it over the whole building, so up to level 3. Then we have something called location line, and that's how to draw it according to reference here. So if I would have this wall center line, then if I take this point, then half of the wall will be here and half here, which is not correct. So I'll switch with this one to finish face interior, because I want to follow this face here. Then chain here is just so that I can use less clicks. Otherwise I need to draw one element at a time. Offset is if I want to offset it according to my reference, but that's not necessary. Radius we cannot do with impact. And the last thing is to switch the join status from allow to disallow. And this one is if it says or if it's set to allow, then it will merge the corners, which is not something that we want in a precast building. So I'll start draw, and you'll see here on the right side that the building will start popping up. And we'll draw the whole facades, and then we'll use some other functionality to split up the element in smaller pieces. So I'll start from here and just work around the building, and you see that we're getting the element in real time. So we'll need to snap correctly as well, so we don't get any wrong angles, but it's very easy. And then the last wall. So now we have the whole building, and then we can escape 2 times to end the command. And we'll get this one popping up. It will say that we have walls that cannot, or we'll have walls that there will be no lifters for because it's too heavy. And that makes sense because we have 2 whole facade elements. So we'll just say apply to all if this will pop up more times, which it will probably do, at least for these 3 walls, and say okay. Because this is basically just a warning that, yeah, please be aware that you have made a wall that is too heavy for any lifter. So now it will generate walls with different panels and lifters and bracings. And we can see that. We also have panel or panel thickenings around the lifter so that it can be so everything holds basically. So that's great. This is a good result. And we'll go to material. So this is the steps we have done. And the next thing is to draw the inner walls in the same way, basically. So I'll go back to my command here, or to Revit, sorry. And the inner walls is these blue ones. So I'll start the same command, draw walls, but instead going with the inner walls. And WP20, and do the same setup here. So from level 1, height, and then I'll do, or sorry, it will need to click in the 3D or in the plan, because otherwise, if I would be in here in the 3D, I need to set the level, but if I'm in the plan here, it will get the level automatically. So it's level 3 in finish face interior, and disallow is always remembered. And then we'll just do the same. So follow the reference. And when we come here, we cannot continue. So we'll just escape 1 time, because then the command is still active. And then zoom in on the top and then draw. And it's the same here. We'll just split the walls later. So we'll just continue. And here in the corners, as well as I didn't mention it for this sandwich walls, but you don't need to care about the corners. If you have a gap or if it's overlapping 2 walls, we'll fix that later. So we draw the whole wall here, and again escape. And we won't forget this small wall here, so draw it as well, like that. And lastly, these 2 walls. And then escape 2 times, and the same will happen here. Yeah, probably 2 heavy walls, but then for walls that have or where the lifters can handle the mass, will get the lifters and bracings. So we'll let impact work, applying all the things here, and then the next step is to split the walls. We can just go and switch here first. So split walls, and then this one should be done now. Yeah, it is. So we can see here that we get lifters in some of the walls, but not all of them, which makes sense. So if we go back here, and this is where we're gonna start. We're gonna start with splitting the walls vertically in for the external walls, and then for the internal walls. So let's get started. I'll have this one or this one here active so we see what happens and what I'm selecting because it can be a little bit tricky here. Anyways, the functionality is found under walls and then split wall vertical. So for all commands, we'll get some prompt down here in the left corner. So it says please select walls. So I'll just select my walls, and it doesn't matter what part of the wall I'm selecting. So here I took outer panel, here inner panel, and here insulation on this one. So it doesn't matter at all because Impact will realize what walls it is. So I'll say finish when I'm done with my selection, and then it says please select reference planes, and in our case it's the grid lines. So I want to split according to grid 2, B, C, D, E, F, G. So these ones, and then hit finish, and then this dialog will pop up with information or yeah, where we configure the split basically. So first of all, it's a gap, so we'll have 20 millimeters, and then what end cap to use. The end cap is the edge geometry profile. So I'll select, sorry, the 801. So it looks like this, a straight connection. This one I don't need to insert now if I don't want to, because we're gonna connect the walls later with another functionality, but we can just use it anyways. So we say okay, and now we can see here that we'll get the splits of the walls. So it will divide the walls, update the lifters and the bracings, and now we will see that all walls should have lifters, and that's the case. So that's great. We'll do the same here for the inner walls, and it's the two long walls here. So we start the same command, split wall vertical, select the two inner walls, the big ones, finish, and then split according to grid 2, finish, and then we'll have 803, which is the straight connection for the inner walls, and then hit OK, and the same will happen here, and we'll probably get lifters as we do here, and that's great. So now when we have splitted the elements vertically, we'll do the same horizontally. So now we don't need a plan because it's tricky to do this step in the plan. So we can just take this 3D and make it like this, so that's the whole building. And then double click on the mouse wheel to zoom extend so that we have it like this. So now I'm gonna split horizontally so that we have the, because this one is level 2. So this is where I have my level 2 floor. And now we have the walls covering or going from the bottom to the top of the building, while I want to have the, yeah, one for each floor, of course. So to do that, we'll start another command just below the split wall vertical. We have split wall horizontal. And the prompt says select walls. So I'll select walls. Again, just one of the panels or insulation. And we start with the outer walls, so no inner walls this time, like this. And yeah, I'll just make sure that I have all my walls like this. That's great. And then I'll hit finish. Then we need to specify the method. So here we only have the end cap, so it's we don't need to do anything there. But for the vertical splits, we just selected one end cap because it should be the same on both sides. But when we do it horizontally now, the top or the top of the or let's say the bottom of the split, this is the split here. So the bottom will be the top of the wall on floor 1, and the top of the split will be the bottom of the wall on floor 2. So these cannot have the same profile for the end cap. So we'll need to configure that. So for the end cap bottom, I'll select the 812. So looking something like this. And then for the top, I'll take 808. And here we can see that, yeah, the walls are probably fine, but since we are changing the profiles, we need to also extend one of the walls of both. So we'll take the top element and lower it 80 millimeters. And that will mean that this one, the top wall will be 80 millimeters longer or higher than before. So that's great. Then we have the split breakpoint, as it's called, and it's how to split. So we have 3 different options. I have some explanations here. So we have wall height from bottom is the first option, and then it's you specify a dimension or a measurement. So in this case, it's 2 meters. So if I do 2 meters and then we'll cut it in 2 meters, and then the rest of the, now I made a very tall wall, but the rest of the wall will be like this, like in one piece. The second option is this maximum wall height. So it's a little bit similar. We put the height like before, but instead we'll cut every 2 meters in this case until we cannot, the wall is not having or it's not taller, so that we can do even piece here in the top. So then we'll just have the rest up there. Then the third method, and the one that we're gonna use, is elevation. So we are gonna select a level, a floor. So we'll do it like this. Make sure that everything looks like mine here, and say OK. And then we'll need to select the level, and we can do it here. So we are sure that it's floor 2 for building 1. Click it there, and you also get a preview of where the cut is gonna be, and then hit finish. And again, now impact will work. Cut the element and update the lifters so that they are suiting. So now we'll probably have some of the walls getting a smaller lifter because of that the wall is lighter, and then we don't need to put the biggest lifter that can be, yeah, more, both that is bigger, so it's harder to fit in the element sometimes, but also that it's normally a little bit more expensive. So we want to be as efficient as possible, but still insert the the components or lifters that can handle the element weight. So now it's one wall done, and then we can just say apply to all and then keep. So we don't need to update the lifters again. We'll do the same. Now it will also load a little bit, but when it's loaded, we'll do the same for the solid walls, so that all the walls have the correct size. So one wall for each floor, basically. So we'll just wait a couple of seconds. It's a lot of things done in the background, so sometimes we need to let impact be completing the commands. Like that. So we'll start command again and select the inner walls in the same way. And here you see that if I click 2 times, it selects or deselects. And you also see, yeah, it doesn't matter if I zoom in, but next to my mouse arrow here, when I've selected, I have a negative or minus symbol, and here I have a plus. So plus will add to the selection, minus will remove, of course. So click finish, and here we'll just have some other end caps. So top will be 1 or 001, and bottom, or yeah, the first one for the bottom will be 001, and the second one for the top will be 00. And then we're gonna split because they are in the there are no gap as we did for the sandwich, but it's even. So we'll just add positive gaps to create some spacing, uh, some tolerance. And use the elevation method. So click OK and select level 2 and hit finish. And now we'll split for the last time. So great. This is the model that we have created until now. And yeah, all elements are there. Then, as I said, some corners will look a little bit strange. So this one is overlapping. This one is missing something. Doesn't matter at all because this is what we're gonna fix now in the next step. So the next step, if we scroll down through the steps that we just did, we have something called connect walls. So connect walls is the next thing to do. And connect walls is basically fixing these situations. So I could have been very careful when I drew the walls from start and made sure that they are correct length and how I want them and so on. And then apply end caps so that they can be connected and so on manually, and also some custom materials. But instead of doing everything like that manually, I'll just draw my wall, split it as we did now, and then use what we call joints to connect the walls. So we're gonna go to level 1 in the drawing. So it's up here. If you have closed it, it's just double clicking up here. And then we can also, this one will pop up automatically from Revit itself. So we can just hit save the project so that if something would happen, then we can go back to this point. So in level 1 here, we have in each corner we have these texts which indicates the name of the joints. So the joints are in the corners and in the straights. So to fix the corners and connect the walls, we are going to start the command to connect. So in the bottom, we have connect walls, and you do that by selecting the wall one by one and hit finish. And now Impact will read through the model and find a suitable joint. So what we can see now is that even if it's a little zoomed out, is that we have the joint, it looks correct, the name is correct, but the thing is that the connection is on this side instead of this side. So to fix that, we have different options like this, so that you can insert the joint according to the reference. So we hit OK, and here it's yeah, possible to change configuration of custom materials. Later in this course, we will look through this and basically create our own joint. So we'll just say OK here and look into the details a little bit later. So now it applies the joint and connect the walls, adding end caps and custom materials like this. So, and we can also see that the end caps are according to the profile or to the reference. So we can see that we have 803 on several places. So now, since I applied this one, we can quickly just or easily connect the same joints several times. So if I would do 802, I need to restart command, but if I continue with 803, it's easy. So here we select, and then we need to just decide the order of it. So it looks okay, so we hit OK, and it will get applied like this. So we'll go through the whole building. So this is the outer corners. So we'll apply this to the outer corners and follow the reference, of course. So this one and this one. And this one needs change. And as I said, if I would select it wrong so that it doesn't insert it according to the reference, then you just select the two walls again and apply it again. It's not more complicated than that. Looks good. This one needs to be rotated. That. And now we're done with all the out corners. So I'll escape the command, start it again, and continue. So let's take 802, and that connection is the sandwich walls and the solid wall. So yeah, this one will just have one option. So we hit OK and hit OK here as well. Looks good. And I'll go to the other side because the building is symmetric. So it's quite easy to find where to apply everything. Great, and we only have two of those, so I'll escape again and start the command for the next one, which could be this inner corner without solid wall. Looks good, so we say OK and OK. Same here. So it's just repeating the steps, and I'll do all the corners so that we have that done. So but it's just gonna take some time. So now we have all the outer corners of or all the corners of the sandwich walls. So we can continue with the straight connections. They work a little bit different. So here I have a straight connection. So I'll just select two of the like normal. Then we find the joint, which is the same, this one as well. But here, since it's straight, then Impact cannot know exactly where we want to insert the joint. And this is, of course, we can put it in the middle here, but we can also use this one to move the joint. So if I want to move it here, I can click there instead. So this is like the center of the joint, and I'll just put it in the center here because I don't want to move it. But you can use the same command to move it, so that's why you need to pick the point. So something like that, and then we continue with the rest of these. And this is a straight symmetric joint, so I won't change the options here, as you see. But since there could be, that you can have different cast materials and different end caps and so on, we'll always ask you to check. So that's why we pop up this one, because there could be just a small change in the end cap that Impact cannot see, and then you need to decide, of course. So even if it takes a couple of seconds, it's a lot that happens automatically. And this one. Great. Then I saw that I missed these ones. This is not the corners, but it's connecting with the inner wall. So we need to fix that as well. So start the command, select the walls like this, and finish. And here we have, yeah, the same options, but we'll just use the first option here. And hit OK. And the same for this one. Great. And then we take the inner walls. So we start command again. Now I did it quickly, so you can repeat the recent commands by right-clicking. So this is when you're a little bit more used to the application, of course. Otherwise, you just start it up here as normal. So we take this corner first and switch option to this. And same here. Looks good. Something like that. And then the last corner or corner joint is this T connection. And we switch option so that the connection is on top here and say OK. Great. So now the connections are done for the whole first floor, but we can here we can clearly see that it's not done for the top floor. So we'll also have a look at that, or basically do the same on the top floor. So I'll just start level 2 and go through the same here. So I'll start with the same corner. I'll just do it a little bit more quick now with less explanation as we did it before. So now the whole building is done. So everything is connected, and the whole or all elements are individual ones for each floor. So that's great. So the next step, let's go to the porous material. So now we have connected everything. We went through both floors and both solid and solid walls and sandwich walls. So the model will look something like this, and if we compare and do the same here, it's more or less the same. So that's great. So the next step to do is to add the openings, which we're gonna do now. Yes, so the openings is also a combination of Revit and an impact. So we are using the Revit doors and windows, but then we are applying, for instance, end caps and information if they are mounted in factory and so on, as we can see here. So in the same way as we did for the joints, we'll add the openings. We'll start on level 1 here, and in the reference we'll see the text, and that's the name of the openings. So I'll just start, and the course material suggests that we start with FD2. So we'll take that. So it's in the wall commands, draw opening, and then we switch to sandwich walls, and we find FD2, which is the door. And then we can just hit OK. And yeah, it is a little bit tricky to apply it 100% correct. And this is due to the insertion point. So just put it as close as possible. And the more you zoom in, the more you can have it accurate. So there when you zoom in enough, you'll be able to put it accurate, and you can always move it afterwards. So and since this is like a training material, we can just do try a little bit in different ways, but yeah, if it would be real, if you do something wrong, you can just move it after. So we click there. And now we get the question if we want to update the lifts because the weight have changed, and that's pretty obvious because we have changed. We have removed a lot of material because we have removed all the insulation and concrete for the door. So since we're gonna add a new another opening here, we can just say keep. But if this was the last opening for the wall, we can just say update. I'll just start keep and then go here, FD2, and do the same. So there, and keep. And then here we can see that this cast material, the bracing, is in the middle of the opening. So we cannot, it will be deleted. So we just click delete instance. This one will be updated later on when we, instead of saying keep lifters or keep lifts, say update. But now we just say delete. That was the lifter or the one. And now, since we needed to delete, the command restarts. So we'll just select the same again, FD2. And so we have those two, and we'll just continue here. Like that. And we'll keep, delete that one. So don't worry, it will be up. added again automatically when we update. So this second or last FT2, I think, on this floor, we can say keep. So here we see that it's not 100% aligned, but this one we can move later if we want to. I'll just keep it like it is here, but or I can move this one to show here. So we have something with called edit opening. So then we just select this, and we can say move from here to here, and it's yeah, we'll just keep it. And it's aligned. Okay. For some reason it will. Okay, I'll just hit update there, and then say okay to end the command. So that's how you do it if you move it. So we'll continue. So that was all FD2, and we can continue with the F21 now. So draw opening, F21. And yeah, this is the last opening in this wall. So now I'll click update, and then the same for this bracing. So so it will take some time to apply these, but the thing is that we are doing a lot of things at the same time. So it requires that Revit has some time, Impact and Revit has some time to work. So we'll continue with the next F21. There we have it. And the same there, it's the second one, so update, then delete. Great. Then here. So we'll just work around the whole building. Great. So then we have all those F21s. Then we can go with F3, and F3s are the whole wall here, and then we have in this area here. So quite a lot of them. So draw opening again. It's the same procedure. Then we can start up here maybe and go down. And yeah, the windows normally comes in or the bracings will normally be placed in the middle of the windows. That's why we are getting it like this. F3. Oh, that one I should have hit update on. But that we can do now. So if you don't click update, you can just go and yeah, the easiest is maybe to go and click edit wall and then say okay, because then it will trigger. Or we also have insert update lifts. So here we trigger it. So update and then save it. So if you want, if you don't want to go and edit, I'll just show you another functionality. So insert update lift and then just select the wall and then just say okay. So we'll continue with drawing the F3s. Something like that. Update lift. Start the F3s again. We are soon done with them, or a little over halfway at least. Something like that. And then we have these here on this side. So then we have one left here. So then the F3s are done, and then we should only have this north facade left, but that we can see in a second. Did all that, all this, and yeah, we should be able to, or we should only have that one. So we take the F14Bs. There we have it. And update this wall. This one as well here. And lastly, for the facades, we have the F1. So we start and select the F1s here. And then when this one is loaded, we also have the D2s in the inner walls. So that's the last ones, if I didn't forget any. So D2, and do the same. Yes, something like this. And if we go to 3D now, we'll see that all elements or all openings are inserted, which is perfect. So now it's like for the joints, it's time to do the same for floor number 2. And in the same way, I will just do it, but not comment on it. So yeah, we'll just go to level 2 and basically do the same procedure again. So now all the windows and doors are inserted, and this is the result. So yeah, the next part, if we go through here, this is all the windows. So the model looks like this now. So next part is we're gonna use something called cast-in material template. So we'll click here and I'll explain what to do. Yes, so the cast material template is a functionality that will add the cast materials automatically to elements for the walls, not elements but walls. And it's for example these cast materials, the tube here in the bottom and the socket in the top. And it's like cast material that you will add to almost all elements. So instead of doing that manually, you can add it with this or set up with this template and add it. So we're gonna start and we're gonna do an example of this for solid walls. So we're going to the yeah to the list of commands for walls, and then we find sim template, cast in material template. So sim is the, the name of it. And we'll create a new one here on project level, and it will be called WP, sorry, 20 dash vertical, like this. And yeah, it's going to be insert in top, plastic tube in bottom. So it's just to give some information of what we're actually going to insert with this template. And then we see this dialog, and first we have this called table of sim. So here we are configuring the cost materials, and then we configure how to place them in the different sides. So we'll click on new here, and this is for solid walls. So we'll select wall, and we start with the bottom. And the bottom end cap that we inserted in these elements is this 001. So VD 20 001. And there we go to category or group 5 hole, and we're gonna insert 0505. And we do the left side, and it's gonna be inserted here in B, and then we are going to change to 100 millimeters. So that's it. Then we say OK. And now we have configured the custom material for the bottom. Then we'll repeat. So click new, select wall, and select VD20 000. That's for the top. Then we're gonna have the socket. So go to 02 fixtures, and we're gonna select 0210. And we switch to left, and also this one 100 millimeter in, so that both are in the middle of the wall and on top of each other. So we hit OK. So now what we have done now is said that OK, if these end caps exist, then we're going to insert these cast materials, and then according to what settings we did. But then the next step is to decide how to place them, and then this particular sim template will be for top and bottom. So left and right won't be something that we work with here. But yeah, for the top, if this end cap, sorry, this 000 end cap is there, how do you want the cast material, in this case the socket, to be placed? And we have two options. Either have this yeah, A and B values like distance from edge, and then a center value. or we have this part of length. And we're going to use the part of length and use, yeah, in the where A is 4. So 25% in of each side, we're going to insert this. And just to be clear here, that when we insert this in this way, it doesn't mean that it needs to be exactly like that. You can, after applying this, you can move around the cast materials. This functionality is more to get it in a place where it's more or less correct. And if it's not 100% correct because of, yeah, some window or something else, then you are able to move it as if you would draw the cast materials to yourself. And as we want the top and bottom cast material to be on top of each other, we're going to this placing bottom and do the same. So setup number 2 and yeah, A equals 4. And then these right and left, just to make sure that if we would like to have any of these end caps in the side, so that we don't get any cast materials, we'll just set everything here to 0, because then we don't risk anything. So 0 on everything, and then we are done. So we say OK. And OK again. So let's try this. But as we remember, when we splitted the walls horizontally, so between floor 1 and 2, we set up these end caps in this command here, split wall horizontal. But we don't have any end cap on top here and on bottom in the floor 1 elements. So before we apply this, we need to make sure that the end caps exist on both walls on both sides, because as it is now, the result would be that the top wall here would get the plastic tube, and the bottom wall would get the socket, but the bottom wall wouldn't get the plastic tube, and this one won't get the socket. So we need to make sure that the end caps are there. So I'll just make sure to select all the walls like this. That one is forgotten, but now all the solid walls are selected. And then I'll go to my wall commands and say edit a wall. And I'll go to end caps, and here it will say varies, and it's because left and right, of course, they varies because we have straight connections like here, and then we have the corner like there, and then we have this special one here, so they vary. So we won't do anything on left and right, but on top and bottom we'll fix, or we'll make sure that they are the same. So top should be this 0, 0, 0, and bottom 0, 0, 1. They are exactly the same, like just straight, but in this example, in this course, we have divided them just so that we can use this cast material template. Normally, it will probably be some differences between the top and bottom geometry, but now we just have it straight. So we hit OK, and now this will be applied, and we won't see any difference since it's straight, but it will be there, and that's the important part. So it will soon be done. We see here a progress bar in the bottom left. So it's almost 50%. Now it's 50. Great. And then we can save. If that one pops up, it won't pop up at the same time for you and me, but because it depends on how long we have had the project open. But now this is you know, all the walls are prepared, so we can select them again. and this time we'll apply the template. So again, in the wall commands, but then here apply sim template. And then we find our template on project level. So we hit OK, and the impact will now apply the custom materials. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16 walls. So it will take some seconds, but here we are. So now we see that we are getting the lifters, or not lifters, but the sockets and the pipes, and they are on top of each other so that we can switch to wireframe here. We'll see that on site when we put the pin here, then we can fill in with concrete and attach the elements. So that's great. So this is how you do it with this template. And normally these templates are prepared for for things that are pretty standard in your projects, not only in one project. Of course, you can do it for one project, but it's more something that will happen every time in every project when you use a wall, for instance. But then it could be something in a specific project that you will do on several elements, not all, but several elements, and you don't want to set up this template. Then we have a functionality that is like a hybrid of this. So it's like, yeah, it gives you the possibility to apply the same things on several elements, but at the same time you don't need to make a configuration. You configure it by inserting the custom material to the first element. And let's, instead of me talking about it, I'll just scroll down from the steps we have made, and I'll show you instead. So this functionality is called Smart Sim. So I'll click here and we'll start that. And we'll work on this wall for the example. So I'll go to Revit and select this wall, go to impact, and also underneath the wall definition or wall commands, we have Smart Sim. And here we are, we're gonna start with the configuration. So first of all, we're gonna, in this configuration, for this functionality, we're going to add some welding plates in the corners, just so we have something to test. And we'll select from common level fastening plate, so group 3, and we'll find one called 0311, like this, and I'll hit OK. So what happens now is that we are getting it inserted, or not inserted yet, but we're getting this row, and when I click there, we see actually the preview. So now it's just outside the element. So what we're gonna do is we're gonna configure where the element should or the custom material should be placed. So first of all, we need to place the first instance. So this is going to be placed, let's see, it's going to be placed 200 in both X and Y direction. So as soon as I click out of one cell, it will make the change. Then we have three parameters that will control how they are spread out, and they are also like you will use two of them, and the third one will be calculated by impact. So in our case here, we will use the we'll place 2 instances and uh, have an end offset. So this means that the spacing between the two will be calculated. So it's a little bit small here, but it's a grayed out text. We'll see it now in the Revit. So we skip spacing, add 2 instances, and do 200 end offset. And now the third one will be calculated. And this one is is done now. We don't need to do anything more. So we'll just click new, select the same plate because we want the same in the top. So the X value will be the same, but then we want it to be placed up here. And how do we know this placement? So either if we have like a special, if it's not rectangular here, let's say that you have some recesses or something, then it might be a good idea to make the measurement yourself. But if it's just rectangular like this, and we are taking the outer profile as a reference, then we can look up here where it says the length, width, and height of the element. And the height is 2590. So we'll probably put something a little bit less than that. So it's not exactly, yeah, I see here that it differs 10 millimeters. So I'll put 2.4. So it's not gonna be 200 millimeters here, but it's gonna be 190, but that's fine. So we put 2400 like this, and it will be placed up here, and the same with 2 instances and end offset of 200. And now we're getting 1 in each corner. And you can see here that the road that we are working on is green, so they highlighted green, and the other one is red. And the ones that are already inserted to the element, they are blue. So it's easy to see what is what basically. So now we are done with this configuration, and I could just click OK and get these placed here, but that's not really the thing I want to do, because I want to do it on this wall and then apply it on a few more walls. So before I click OK, I'll need to save this. So I'll switch from common to project because I want to save this configuration on project level. And then I'll click the save button here in the bottom. And I can call it corner plates 0311, which was the custom material name in each corner, something like that. And OK, and then we have saved successfully, so that's great. So now we can just hit OK to apply, and the plates will be placed like this. Now I didn't make the correct measurement, so this one should probably be a little bit out, but it's not really the point of everything being correct. It's just showing the functionality. So I hope that it's fine for you. So the next thing is to do that on the rest of the walls, and we will do it one by one because all the walls have different lengths and so on. So we need this command just works on one wall at a time. So instead of yeah, I'll just do it. So start the smart sim command, and I'll click on this one now. And instead of starting configuring, I'll switch to projects and corner plates. And now we will just fetch the configuration like this, and then hit OK. And this is the result. So I'll do the same here. I'll just go through all the walls so you can do the same. Yes. So now all the walls have this cast materials in the corner, and yeah, it's this example. I made it or applied this smart sim to all walls. So the difference between the sim template that we just looked at or the smart sim in this example, it's more or less the same, but in reality, the sim template would be more for all walls, while the this smart sim would be for a few walls. So let's say like out of these, that I would do the same on 6 of the walls. Then I would use this smart sim. But if it would be on all walls and so on, then maybe it's a good idea to create it on the sim template. So the purpose of showing both is that you should know both, and you should also be able to pick the one that both you like but also makes sense your in your what's called in your case. One other difference here that we noticed is that when we do the smart sim, we don't need to think of what Endcaps is inserted, and that's something that could be positive. If let's say that on these walls that we are, the solution should be the same. We should have the cost materials in the corner, but instead of yeah, maybe we don't have the same end cap in the top, for instance, then it would be hard to use the sim template. So yeah, two good tools that are useful in similar situations, but yeah, we'll see which situation is best for the different cases. Yes, so let's go to the next part. So again, everything is explained here. So this is, yeah, isolated walls, but we see um, we see that the welding plates are in all corners. So the next thing we're gonna do is to draw a recess from external model. And this is one of the main advantages in Revit is that we can get like a IFC or a Revit model um, and link it like we did with the, if I go here, yeah, when we linked the grid line reference, then we linked like a 2D CAD file, like a DVG. But in the same or similar way, we can also link as IFC files or other Revit files and use those as reference. So that's what we're gonna do now, and we're gonna make some recesses from it. So we will go to the insert tab up here, and before we use this link CAD, but now we'll do the link Revit. And the same way as we did before, go to Project Manager, right click on Drawings, open folder, and then here select the whole path, copy, and then we're gonna paste here, enter, and then go to the common drawings, and here we find the MEP project. So this MEP project we just select and hit open. And what will happen now is that we will get these pipes in the model. And the first thing we notice is that, yeah, they are going through a wall here. So we need to make something to make it work. So I'll go to the level 1, but yeah, here I already have it open, but we are not gonna use the level 2 for a while, so I'll close that one as well as the cover. So right now I want only level 1 and 3D open. So level 1, and we can see the same here that they are going through the wall, which is not optimal. So what we need to do is to prepare a view so that we can make the recess, because we could of course insert it here, but it's a little bit tricky because you know what to snap on in 3D. So I suggest that we create a section and do it from there. And the sections can be found in view and then section. But also it can be found here in this quick toolbox, or what to call it. So we click it, and then I'll just place it on this wall here. So from here to here. So if I do it from bottom to top, it will look, you know, in this direction here. You see the arrows. If I do it from top here to bottom, it will look to the right. So I want it to look to the left, so do it from bottom to top. But don't be, yeah, if you did it the other way around, then it's fine. Just place it like this, and then it's we have a flip section arrow here. It's a little bit tricky to see, but it's 2 hours arrows, so you can just flip between the two views. And at the same time we are getting this, or not not getting, but placing this. We also see that here in the product browser that we got a section. Maybe we didn't see that before, that it was not existing, but it wasn't. And the section here will show up, section 1 and section 1. So you can double click to open. Or if you want to do it the quicker way, so as soon as, or as long as it's selected and you see the dashed line, you can just right click and go to view. Then you open it as well. And yeah, it will look a little bit messy now. Not too bad, but a little bit. So to make it look better, we need to clean it up. So I'll just take or select the view here, the rectangle, let's say, and just make it around the openings. I'll set the scale down here to 1 to 20 so that these look a little bit better. And I'll change the view to shaded and the detail level to fine. Because if I, as it was from start coarse, then you see this one here, depending on what setting you have when you when the external model is created, the level of detail can show different. So here you see that they are yeah, different sizes. So this is good. Now we have everything we need for creating the recess. So we will start with yeah, with one of them. So we'll go to impact, and the recesses, they are components, and you can find it under modifier and draw recess. And there are two types of recesses. So it's the standard ones or the user defined. So standard ones is circular or rectangular, while the user defined is yeah, anything. It's controlled by user, and you yeah, you draw some lines in a closed not circle but closed loop, let's say, and those lines can be used to create the recesses. But in our case, we will use the standard, and since we have rectangular pipes or circular pipes, we'll use the circular recess. But the types here, the default ones, 150, 50, 100, and 200, is not really the exact ones from here, because the left one, this one, is 300 millimeters. Yeah, that can be seen here in the material. So look here, 300, and the right one is 170. So we also want some tolerance around it. So I'll suggest that we make the left one 320. So if I don't find the size here in the type list, I'll just say specify recess size and put 320 millimeters. So then the size is correct. Then the thing we need to do is to decide how deep we should cut the recess. So it's 100 millimeter now. So in our 200 millimeter wall, it will be until middle, but we want it to go through. So if we don't know the thickness, we can just use the cutout. So then it will cut the whole element. Then we hit OK, and we place it. And it can be a little bit tricky to snap on the center, and it depends on how the reference is done and a lot of things. So I usually just place it next to it like this, and hit escape 2 times so that we terminate the command. So now we have it like this, and what we can do now to make it correct placement is to go here to modify and use this align tool. And the align tool is basically just moving a tool for moving with references basically. So we take the reference, and my reference here is, yeah, we'll need to zoom in so we don't get this edge, but so we get the center. And then we get the center. We don't get the point, but we get the vertical line here showing the center. So then it will go like this. Then we could lock it, but we don't need to because we're gonna remove this reference. So we'll find it, and if we're not zooming in, then it might be hard to get the point. Even if we are zooming in, we get this one. And yeah, how do we select it? Because we want the point. So instead of clicking, we just hover over it and use the tab key on the keyboard. So if I do it once, then I will get the point. Then I can click. So now I got it on the first try, but if it's a lot of things behind, it might be that you need to try or put tab a few times so that we are selecting the correct one. So now it's selected, and then we do the same with the horizontal, and you see it will be placed perfectly. So we'll repeat the steps for the right one. So we'll start the draw recess and specify recess size. Switch to circular first, of course. And this one, the right one was 170, so we put not there, but here 190. So we have 20 millimeter here as well, and then cut out, and then just place it, escape 2 times, and let it adjust the size. Go to modify, align, and then now here we got the point from start, and then again here tab like that, and we are done. So now we're having our recesses, and if we go to the 3D, we also see that now the pipes are not colliding with the wall, but we actually have the recesses for it. So yeah, we are done with the reference for the ventilation for now, but we might use it a little bit later. So instead of removing it from the model, we just want to, yeah, not see it anymore. And you do that in the project browser here, in the bottom where it says Revit links. If we expand it, we have the MEP project, which is the name of this model. So we can right click and unload. So unload means that we still have it accessed, or it's linked to the model, so we can start it again or load it again, but it's not active here. So it's fine, and I'll hit save. So that's it. The next thing is to add the reinforcement. So we'll take a look at that. If I go here and scroll to the bottom, we have add reinforcement. So the reinforcement that we're gonna take a look at is the template. So if we go to Revit and go into the reinforcement area here on the right side where it says apply RC template, we can click down, and then we have the RC template, which is the reinforcement template. So RC is just short for reinforcement. So we can click that and switch to sandwich walls, and we can take a look at this WA000. And we won't do any changes, but I'll just explain what happens, or what this is basically. So this template is, as I mentioned when we talked about the wall definition, it's the automatic reinforcement that we can get. So in this case, for the sandwich walls, we are getting 2 meshes in the inner wall or inner panel, and 2 rebars around the edges. and then in the in or out panel we have one mesh and one rebar around the edges. We have some other options here, but this is the option we will use. Then we have some settings on, okay, the horizontal mesh in the inner panel, should that be, or not the mesh, but the horizontal part of the mesh, should that be pointing inwards as it is now, or let's say outwards that is now? And depending on that, we are getting some previews here. And then some covers and how to, how the elements should be cut and so on. Or not the element, but the rebars. So we can take a look at the illustration here. So this is the, this is the lower corner, lower right corner of the wall. So this is the edge rebar. So the two different parameters are placed like this. So the cut and placement. And then we are probably not want to cut the rebars, if it's like 1752, we're probably gonna do it as 7050 because it's quite tricky to do it like cut it on the exact millimeters. So this is a round round off parameter basically. And then we do the actual, decide what to see and so on, or what to use more correctly. And this is the edge reinforcement, so it's like around the edges. So we have inner panel and outer panel. We have the the quality of the rebars, the diameter, and the amount. So in the outer panel, I'll have 2, and in the inner panel, I'll have 1, and so on for each edge. Then I'm using the straight bars, but there is, there are different options here to have different kind of solutions. But in our case, we're just gonna have the straight bars. And then another thing that we're gonna take a look at later when we create our own end cap is that you can also specify reinforcement for the end caps. And then this is where you are putting the spacing between them, but more of that later. Then similar things for the openings. So quality and diameters and quantity in the different sides of the window door. And then you can also have these diagonal ones with to prevent cracking in the corners, as well as how to have the this anchoring. So if you just want a specific length, the element length, or user defined, but we'll use the anchorage length. And also here end cap reinforcement, the same when you have specified reinforcement in the end caps, but now for all sides of the window. And then in the last tab, we are specifying what meshes we want to have. So in this case, we're gonna have 2 N5200s in the inner panel, and then in the outer panel, we're gonna have one piece of N6150. So that's great. And we wouldn't change anything, so we'll just close these dialogues and go ahead and apply this on the model. But in this model here, we wouldn't see the the reinforcement because it's not visible. So we'll switch to a view that is prepared for this, and it's we can take the Revit rebars first, and then we have one with all reinforcement. So rebars will only show the rebars, no meshes, and all reinforcement will show everything. And this is so that we can see what happens a little bit clearer. So I'll double click on rebars and I'll just select all my my sandwich walls like this. So you can select it in different ways, of course. So something like this. Make sure that it's only sandwich walls selected. And once again here, you don't need to select the whole wall, just one of the panels, like this. So now all solid or sandwich walls should be selected, and then we'll hit the apply RC template and select our preferred one. And it will, yeah, it's quite a lot of walls, so it will take a few seconds, but it's very quick according to, or compared to what we get for free, let's say. So now the reinforcement is implemented or applied, and you can see here that we're getting around the windows, around the edges and so on. So yeah, it took a little bit of time, but it's just because we did it for all walls at the same time. It takes around, yeah, let's say 5-10 seconds for each wall, and we have 40 walls here, so that's why we need to wait a little bit. But it's very much faster than doing it manually. And now we only see the rebars, as I said, and we'll apply the same for solid walls, and then we'll switch view to check the mesh. Before we do that, I will also highlight something that we haven't talked about, and that's like we are getting automatic reinforcement or rebars around the cast materials. So that's also a possibility to set up with your cast material, so that you don't need to spend time on that each time. So yeah, we'll select the solid walls as well. So like this here, maybe zoom in so it's a little bit easier to select. So something like that, and apply RC template. And the same one, or the one for walls is VA, so no W, but 3 zeros is the same. So we are gonna apply that here. So yeah, the solid walls are much simpler, so that's a little bit quicker here. And if we switch to the all reinforcement view, then we'll also see that we get the meshes. So yeah, we're done with the first part of the training, which is the walls. So this is the end of this part. So we'll click the next, which is save the walls. So now we have prepared everything in the model, and now we also need to save to the database. And we're gonna save the walls on yeah, with some different element marks on the floors. So we can go to Revit again, and I'll close my rebars and also the close the section. And here in the 3D, I'll select all the sandwich walls on floor number 1. So basically just doing like this, and the same, we don't need to select the whole wall, just one of the panels like this. So now all on floor 1 is selected. Then we go to the impact tab, and underneath the smart sim right now we have save walls. So the first yeah, then we have some things happening here, some loops that are on top of each other. So we'll just hit OK, because now when we're saving, we also check for conflicts. So it could be that two were placed on top of each other in this case. So what happens now is that we create assemblies. So that's why we have this progress bar down in the bottom left. And the assemblies are later on used when we are generating shop drawings. So it will soon be done. like that. And impact will suggest element marks, so SW that we recognize from the definition, like the prefix of the mark, and then starting from 0, 1. But we want the first floor to be called, the first element on the first floor to be called SW100. So I want to rename them. So I'll select everything like this or something, renumber selected, and just put SW100. And before hitting apply here, it's good to just check here that we have 20 out of 20. So if it's like, if it would say 18 out of 20, then I probably forgot to select all in my list. So it's a way to just double check that everything is selected. And then you hit apply. And then what we do now is we take the first element and call it SW100 and then continue. And then we have this, yeah, just confirmation that it was completed. Yeah, then hit save just to start the process to save to the database. At the same time, I can talk a little bit about this. So now we see a lot of ones here. I don't know if we have any that have more than one. This is yeah, how the elements in Revit works or impact. So if we have one element that is identical, so two elements that are identical, sorry, not one, but two elements that are identical, like, yeah, really identical, same component, same size, same reinforcements and so on, then we will save them as the same mark. So let's say that it could be SW109, but then we put the sum to 2. So we'll have 2 of the same element mark. And this is of course to save, save time on creating just one drawing and so on. Then we have this export to OBJ, or OBJ, sorry. That's for very special elements, or for elements, yeah, let's say we are saving a stair or we are saving a column foundation, then we don't have, or impacts don't have the information from the database how to show them in the model viewer here in Project Manager that we're gonna check in a second. So then we have the OBJ, and instead of then just yeah, showing what we can from the database, we are actually showing the exact geometry. So here we see on the left part of the picture um, that we are getting, or this is from Revit. So I've saved the left one with OBJ and the right one just normally. And this is in the project manager. The left one looks exactly the same as in Revit, while the right one has some some issues, and that's because this shape is not something that is supported directly in the database. So it's just to help us with those special situations. But yeah, for all our walls, we didn't, or we can do like this here. We didn't put any checkboxes here in export obj, so we'll just save them normally. And that's how you do it normally with most elements. It's just the special ones that is not exactly the same in the project manager, that you can save with obj. And now you can see that we have now three elements to be saved. If I'm in the bottom here, of course. So we'll wait until that's done, and then we can take a look at the ones. So now it's all saved, and we can see here that none of the elements were identical. So we close here, and we can continue saving the second floor. So just the same procedure here. save walls, and then the same as before with loops. And yeah, we'll will just also rename, because these ones should be SW200, so we know that they are on the floor number 2. So we hit OK and save. Great. So then we can continue with the inner walls, and yeah, I'll just keep the inner walls with the same name, even if they are on 2 different levels. Just to make it a little bit quicker. So like that, and basically the same process as for the sandwich. And here we can see that one of the walls have 2 instances, so that one will be, yeah, saved with the same name. So we start with W100 and apply and confirm and then save. Great. So now everything is saved, and we can go to the model viewer here and just go and update the model. And then we take everything that is saved to the database since we opened the Revit model or created it. And yeah, if we don't see it, we can just double click on the mouse wheel to get the elements. So this is our building, and now I see it in not that much detail. Then if I go to view up here and switch detail to from coarse to fine, for instance, then I will see a lot more details. But then again, or not again, but if the more detail I see, the more time it will take to load it like this. So that's great. One more thing before we are going to take a look at the next chapter is that let's say that I've now have I have saved these walls, but then you start working, you save again, and so on, and then in the end you don't really know which one you have saved and which one you have made some edits on. So to do that, we have another view that is prepared called impact update status, and it's this one. And now it's everything is gray because I have saved everything just recently. But if I would just as a test draw a wall here like this, you see that it's going to be like pink. That means that it's unmarked, also known as it's unsaved. Delete this one, and if I would do some modification on one of my elements here, let's take this for as an example. So if I would just move this one like this, it will be orange, showing that this one is saved but modified. So then to get it green again, I need to save it one more time. So if I do that, now I change this, but it's fine for me. So then I can save it or resave it, and it will take the same mark. So we'll just save the new position to the database. And all of that, or we have an example of that here in the bottom of this. So this is how it could be when you work on a project, that these are not saved and not these either, and then you have some that you have made some changes on. So yeah, it should be saved any minute now. But the next thing we are going to take a look at is the beams. So let's take a look at that. So the beams, we'll just go ahead and click to get started, and we start with a definition. So before, or not before, but the element type before we looked at was the walls, and there we also started with the definition. And just to yeah, repeat a little bit, the definition is the combination of impact functionality and database information and the family from Revit. But the difference now when we look at the beams is that um, a beam family is so-called a loadable family in Revit, which means that you create the family in a separate file and load it into the project. Compared to a wall that is a system family, that means that it's created in the project, so no external file basically. But yeah, we'll take a look at the beams, and we'll go just where we were now with the walls. We have the beams, and yeah, the list is much shorter because the beams are not as complex as the walls. So we'll start the beam definitions, and we will look at the IT58. So it's it's an inverted T-beam. So we'll edit that, and yeah, even if it's a different type of element, there are some patterns that you will soon figure out. So one of the pieces in the pattern is that we always start with the general tab, and in general tab we are defining the geometry and the production. So in the walls we set up the material and the thickness of the plates. Here we do the size or the cross section of the beam. So it's like it's different but still the same. So yeah, here we have three different options. I'll go back to the course material. So the first is that we have a predefined beam family. So basically we just load it, select the beam, and from that family will read the size. Or we have we use the different section types. So in this case, a inverted T, fill in the values according to this legend. And when the values are there, we are creating a family, and Impact will create it for us. So like this. Or the third one is a user defined. So it's like now I have the same shape as an inverted T, but it could pretty much be any shape that you, instead of having a family or configuring in the parameters, you just draw some lines in a closed loop and create a family by picking these lines and creating the family from it. So these are the three different ways of doing this. Um, yeah, and then of course material, what material to that the beam should be consisting of, as well as the production line. And this we remember from the walls is yeah, the limitations or warnings that we can get from limitation in the factory. So the size of the mold and the capacity of the mold table and the cranes in mass then. Then if we go to the second tab, this one doesn't exist for the walls, but this is the chamfering. So here we can add the chamfers on yeah, any of the corners. So you decide the size of the chamfer if you have yeah, if you want some text for it, and then here you decide which um, which corners should have it. So if you take a look here, when I uncheck and check this checkbox, it will be added or not. So then we have the lifters, and this is pretty much the same as for the walls, for the beams. We have 1 to 4 lift points. We have the minimum distance between two lift points, and so on. What's not here is the side lifters, but we don't have side lifters in a beam, so that's it. Also, we can have lifts in single line or double line. So double line will be more like a slab, but single line will be just normal. Yeah, and then it's the placement and so on. So this is very similar to the wall, as well as this. This is identical. The only thing that is differing is, of course, our values. So for instance, the prefix for element marks for beams is a B. So that was the definition for beams quickly. So let's go ahead and check the the next part, which is draw. So we're gonna draw the element in the model. So the the beams are gonna be placed on level 2. So I'll start level 2 if I don't have it open. And if I zoom in here, I see that I have a reference for the beam. So I'll go up and start the draw beam command. Go on project, beam, and it was inverted T section, and this IT 58. So this is what I'm gonna work with. So then we're gonna start here, and before we start drawing, we'll make sure that the placement plane is set to level 2, building 1, as well as here in the properties that we have start and end extension. So I want a gap in the start and end of 20 millimeters, which means that if I'm gonna click here, the beam is actually starting here. So I'll click there and then here. We can see that that's the case. So then I'll escape once, and we cannot see the beam now, and that's because of the what's called the view range. And the view range is basically since this plan drawing here, level 2, is just a view of the 3D model basically, but it's just not in 3D. So with the view range, we decide how far we are looking. So now we cannot see this beam as of how we drew it. So if I go here to the view settings for the view range and put this to negative 1500, so I want to see 1500 millimeters down, then we can also see the walls on level 1, but also this one. So this is our beam, and the next thing we're gonna do is to make sure that this beam can be fixed on the corbels, because we're gonna draw these columns and then corbels, and then we need some way to make the beam and corbel join together. So that we're gonna do with the beam ends. And the beam ends are can be found in the edit. So we'll start edit beam and finish. And this is the edit beam. So here we can make some changes, change the length, change the section if we selected the wrong one, and so on. And then we get some information about the element. But we can also go here to ends. And the first one here, angular cut, is to make, if you want to have angles in the element. So either from top or front. This one is seen from top, but if you would use the vertical, it will be from front basically. You can also have recess, so there are different setups. So this one is the full width. Then we have some other examples. So full width, this one, path of width, so not the full element, and full width of top. But we are gonna keep that as it is as well. But what we are gonna do is make this fixture recess. So basically a recess to connect the beam to the corbel. So I want to have the circular recess, and it should be single, but also symmetric. So I want it to be in the middle basically. So I'll take single symmetric, and A is the diameter. So let's put 50 millimeters, and then L1 is the edge to center of the circle, or yeah, to the recess. Then I want it to be on the right side as well. So instead of setting up these values, I'll just use this arrow and we'll end up with the same here. So that's the thing we're gonna do. We also have one more um, tab, which is section, and that's like a functionality that you can change the cross section of the beam. So if you have it like this and then you add a rectangular, it will be half-half. Maybe a little bit less common for beams, but for a tall column, we have the same functionality where the first part for the first floor should maybe for a factory, it should lift a like the crane, inside crane, then it needs to be quite big, but then it should continue to hold the roof, and then it can be a little bit smaller. So then you can switch the cross sections. We'll see an example of that later. But anyways, we can hit apply, and with that we will get these holes. So if I go to the 3D, you'll see that we get the holes like that. So that's perfect. The next part is to add the reinforcement to this drawing, or not to the drawing, but to the element. And we're gonna do it with a similar tool as for the walls, but instead of using the RC template or rebar template, we have the reinforcement template for as we did for the walls. We have something called rebar template. So we'll go to the Revit and just go up here to the reinforcement. And before we did this apply RC template, now we'll click apply rebar template. Switch to beams, and then we have this IT. So we hit OK and click on this one and click finish. So yeah, now we cannot see anything, but again, this was because we had different views. So if we go to this impact rebars and zoom in on the beam, we'll see that we have yeah, this setup. So now we used this setup, but we'll later on take a look at how we can create this ourselves. So we'll just close the rebars here. The next part is to do right now, at least for the beams, is to save. So we'll do the same as we did for the walls, but now we just have one beam. So we'll select it and hit save. Change to B100 and apply. Okay, and save. So now this beam is saved and we can continue. And the next part is the columns. So we'll also click to get started, and we'll take a quick look at the definition here as well. So in this time we can just take a look at it from the course material here. So we find it as we did for the beams under the draw columns. So we have the column command, and the one that we are going to use is called RC 40 by 50, and it's on the project level. So the same three options is here as well for the as for the beam. So first we can load a family, and from that family we can catch the size. We can set up, we can select what shape of the or cross section and fill in the values. So in this case, the width and the height, and then generate the family. Or the same as before, the user defined. So have some lines in a loop, select them, and use them to create the family. also setting the material and the production. So this one is more or less the same as for the beams. This one as well with the chamfering. So yeah, the edges you can have a chamfer on. You decided here what edge or corner to apply it. But then here on the liftings, it differs a little bit. So there are two options for lifting a column. So either it's the column side, which is this option. So then we are having the lifters only in the side, while having a recess basically in the middle for lifting it on site. So the lifters on site will be used for transport and production, and then they will put, or you will put a, a lift device through here and lift it like this on site. Or you have this column top, and that means that you get the lifters in the side as well, but also one in the top. So you lift it in that lift. So two different options that you set here in the top. Then you have the same options here. So you decide, yeah, max distance for 2 lift points. So the difference here is that we only have 2 lift points or 4 lift points. Or if you have the one, this option here, column top, then you also have 1 lift point in the top. But for the side, you cannot have 1 lift point in the middle. Then you have the setting with where to place the lift hole. So if you're using this option here, then it's lift hole distance from top. So then it's this distance basically. So very similar to the both the, or more to the beam, but also to the wall. So pretty much the same. And you of course set up the lists with the capacities. And then you put where to place the side lifters. So either center of gravity, part of length, or part of height, I mean, or fixed distance from the side. And then the naming tab is the same, just different prefixes. So let's go ahead and draw the columns, and we're gonna do that on the right side, left side as well. So I'll go back to Revit and go back to my level 1 this time. And here we're gonna start to draw, and I'll start to draw column command, select my rectangular and RC40 by 50. So this is the element we're gonna use. Then we click OK, and we have a preview. So first of all, before we place it, we need to make sure that it's vertical. So the impact doesn't support the slanted ones, so it needs to be vertical. And then we also need to decide how to place it. So it should go now from level 1 up to level 2. So I will switch to height, and instead of unconnected, I will say level 2. And then we'll just make it snap to the reference like this. So that's great. And then we'll do the same on the right side. So just make it snap. And then we can escape. And yeah, now we have the columns as well. Oh, like this. So we can actually be in this view, and the next step is to add the corbels. So that's what we are gonna take a look at now. So there are two ways to insert a corbel. So either by drawing it or inserting it. So drawing is basically that we have a column, and we select that column, select what corbel to place, the geometry of it, what side it should be placed on, and what elevation, and if some custom material should be added. And then we press OK, and we'll have the corbel inserted. So this is a little bit more manual way of inserting. This is not the option we are going to run with, but we're going to run with the insert. But before we do that, we need to take a look at the situation of the corbel, so or column. So if we go to our Revit and take a look here, we can actually just select these three and click on the glasses here, which is the temporary isolate, like this. So if I zoom in here, we'll see that my lifter is going to be exactly where the corbel is. And that's not really a good thing. So instead, I want to move the lifters so that they are on another side. So to do that, I'll go to my level 1, and it's only this one here, because for this one, the lifters are on the right side, which is totally fine. But here, I'll go to the column commands and start this change cast orientation, because we have these lifters will always be on the up in the mold basically, and if we change the cast side, we'll also change what side should be the side up in mold. So I'll go here, change cast orientation, and then the prompt here say specify element front face. So I'll take this face. If you don't know what front face, what's the front face, then you can just, you need to just play around and see which one works. But select the front face, and it will work a little bit. Say okay, because we are missing a family for the tags, but now the lift are moved to the other side, which is great, because now we can cast this and insert the corbel at the same time. So this is the end result. So the corbel, we are now gonna, we can actually go back to Revit and click here and reset temporary height so that we can see the whole building again. And I'll just now select both columns and the beam and go here to impact, and then where we have the modifiers, we go to insert corbel. And we select from common the corbel with socket and the one that is 100 plus 200 times 150. And then OK. And we'll see that we are getting some corbels. But we also see that they are not the same width as the column. So if I would just click here, you see that it's differing. But then I can just select one and right click and select all instances visible in view. Now I only have 2, so it would be very easy to select it manually, but that functionality is quite good to know. Then in the properties, we are getting the corbel, and in the very bottom, or not all, almost in the very bottom, we have the general, which have a parameter called full width. And if we do that, the width of the corbel will adjust to the column. So if you want the full width, you just select and change that. And yeah, this is the end result. So the wall are now, or the beam and the column are now fixed together. So the next thing to do is to do the column shoes, and here uh, I before I changed the width, we could also, instead of using the isolation of the elements, we can use the section box. So let's take a look at that as well. So that's also another way to look at the element, yeah, isolated basically. So just select it like this. It doesn't matter that the callbars are not selected. And then up here, modify, and under view here, we have this selection box. So then it's a little bit easier to see what we are doing. And when we are happy and want to go back to the normal view, then here in properties, we just turn off this section box. So then we are back. So now we have covered all the steps, and the next step is to add the column shoes so that the beam or the column can be connected to the bottom of the building basically. So the column shoes are can be found here under the components for the custom materials, and it's called insert connection here. And we have one prepared on the common level, which is called rectangular for HKPM. So this here, and then click on finish or OK. And then we'll just make sure that we are selecting the bottom face of the column. So like that. Then we see that they are not really correct, and this is because we can rotate this is a rectangular one, so we can rotate which side is or how this is oriented when we draw them. So yeah, sometimes like this case it doesn't correspond, so instead or to fix this we just need to switch here the host height and the host width. So switch from 400 to 500 and 500 to 400. Like that. And now they are the same. So yeah, sometimes it will work directly because then you have rotated the column according to this column choose. Otherwise you need to switch. So you can do that on, or we can do that on both sides. So I'll start the command again, insert connection, the same, and switch. Like that. Yes, so now we are gonna add the reinforcement in the same way as we did for the beam, and we are using the same functionality basically. So we go to Revit again and start the application or a functionality apply rebar template, and switch to column. We have the RC, and say OK, select the columns, and then finish. And it's the same here. We won't see it, so we go to the impact rebars view. We can actually make another section or selection box. So select can just select the columns in this case and do like this, because we are Revit are making a bounding box around what we select, and then we just see that content. So we get the reinforcement similar to the beam, but we will miss it for the corbels. So we can do the same there. Apply rebar template, switch to corbel, and then we have one called C. Say OK and select both and say finish. We'll get some reinforcement there as well. And we can see that there are different colors, and in this standard we have set different shapes to different colors, so it's easy to change or see what's what basically. Yes, the next step is to save the columns, because as for the beams, it's not that much, or they are not that complex basically as the walls. So we can start with removing the selection box or section box and close the rebars, and then we start saving the columns. So we can select those two, and or we can first of all change the course material. So we can either select the columns first or start the save columns command and select them later. And then escape. So it's two ways. Change the name to C100 and then save. So it's exactly the same as so the same procedure for all element types when saving. So now they are in the database, and the next thing we are gonna do is take a look at the slabs. So we can start with clicking this button, and as we have seen now for walls, beams, and columns, we are first going to look at the definition. So let's start that, and you can find it in the slab commands under slabs. And we are going to start looking at the SS19, solid slab 19. And again, we are starting with a general dialog with the geometry. So we have a width of 2.4 meters and the thickness of 185. Here we could also add some tolerance. So if you would like to have some small spacing in between the slabs, but in this setup I don't have that. Then you have the material reinforcement template, just as we had for the walls, and the production, so that we can get warnings if it's too big of an element or if it's too heavy. Then we can get default endcaps, and these endcaps are this one is inspired from the holocore, but these are default endcaps as mentioned. And basically what this means is that when you draw some element around the area you draw, you will have these end caps in this case, and between the elements you will have that. So if we check the material here, we have a illustration. So if I draw this, so the out edges here will be this one, and in between the slabs will be this one. This is of course to save time, but if you don't want that to come automatically, you just set these here to none, and you can then configure your own end caps in the model. The lifting is more or less the same. You have two options, 2 or 4 lift points. So 4 lift points will be placed like this, while 2 will be placed in a diagonal line here. The lift type, same here with, for instance, the angle and the list of the lifts. So in this case, I only have one lift. Then the placing long side and short side is illustrated here. So we have 3 different options for both. So in long side, it's a fixed distance from the edge, part of length, or center of gravity. Then it's also the same. So fixed in the short side, of course. So fixed distance, part of width, and center of gravity. Then we have something called connections, and that's a feature that will help with connecting slabs together. So here we have one alternative. So it's basically a recess and a socket inside it here. It looks something like this here when applied. So it's yeah, it's a tool to insert these, because if you can do it manually with adding a recess and then add the custom material, but instead of doing that in 2 steps, we can do it with the connections. So we're going to use that later. And then the naming is exactly the same as the other ones. So by now, I think many of you or have looked or have seen the pattern between the different definitions. So again, they are different, but we have tried to make it as similar as possible, so we can make it as easy as possible as well. So next step is to start drawing the slabs. So we're going to draw the slabs in 2 ways, and we can see here in this picture that there are 2 colors and numbers of the areas. So the green ones we're going to draw with the points method, and the orange ones is going to be drawn with the line method, so pick line or by model lines. So we'll start with the green ones and the pick points. So we'll go to Revit and start the draw slab command. So we'll need to be on level 2, of course. Then I'll select the solid slab 19 and click here on select boundary and pick points. So before we do anything like this, we'll also need to make sure that we are in wireframe here. If that's not the case, just escape, close the command and change here to wireframe and then go back. And the reason for that is that we then can see a little bit more where we're gonna draw the boundary. So I'm gonna start here in this area and zoom in, just pick the outside points of the boundary. So basically just following here, following the walls and the references. So something like that, and this. And end up here. So this is what we end up with. And the first thing we are gonna do is to look at what directions we want the support length. So the support length can be found here with this button, support length and end cap. And this here is basically the boundary that we drew. So I want to, first of all, we can see here that on this side we have the DD19 3001 end cap and a support length of 80. And the support length means basically that, the slab needs to rest on something. So we are extending the length on this side, 80 millimeters, as can be seen here, so that it can rest on the walls. So in our case, we are going to change so that the right, left, and bottom side, so right, left, and bottom should be having the this end cap, but also 80 millimeters support length. So this one is correct. Then I can switch edge to this one, and the end cap is correct, so I'll just need to change to 80 millimeters. The next one is fine. So here, up here, I will remove all the end caps. So it should just be straight. So I'll switch to not this one, but edge 4. Say no end cap, and then no support length, and then I can use this copy to next function. So it will switch, and then I'll go to 5, copy to next, 6, copy to next, 7, copy to next, and then we are around. And then we hit apply, and those changes will be applied. The next thing we're gonna do is to make sure that we are getting the placement correct. So there are two options for the placement, like the default, or not the default one, but the standard one. And it's either that we're gonna insert from bottom or top. So it's basically insertion point in the elevation direction. We are gonna do the top, but then we're gonna have an offset of this one, because the top is not exactly what we are aiming for. So it's gonna be negative 57 millimeters. Then we need to make sure that the insertion and the direction of the slabs are as we want, and this is not the case here. So first of all, I want to select the direction. So I'll click this button and just click on one of the vertical lines here. And then we can see that we are rotating. So we're getting closer to what we are, or what we want, but we can see here that there are two partial slabs. One that is this big one, it's almost 700 millimeters. Then we have a small one of 80 millimeters. And the reason for that is that we have two is that we extended the the width of this boundary on this side with 80 millimeters for the support. So we're gonna fix that by clicking this pick insertion and then zooming in here. And this is a little bit tricky, but if we follow, because when we drew the boundary, we were following this boundary or inside of the walls. But then if we then also zoom in on the arrow here, or not the arrow, but down here, we can see that we're getting this line, and this line is the vertical line of the boundary, and then it's going here and then not continuing. So this point is the new insertion point, or the new outer corner of the boundary. So if I click there instead, and now just to make it easy to see, because now it's zoomed in, I can just say select the direction so that I can zoom out a little bit. And now we also see, but I'll also just select the same here so nothing happens. But now we can see that we are getting a much better layout for our slabs. Also, we just have one partial slab that is 755 millimeters. So that's perfect. If we don't get the partial slab in the middle, like we have here, we can also move it with these here. but I got it in the middle, so that's fine. And then we are happy, so we'll just click OK to draw. So something like that. And if we go to the 3D and do something like this is what we end up with. So we'll continue with this area. So go back to level 2. And now we are going to draw these slabs with the method model lines, or pick or buy model lines. So to do that, we first need to have the model lines. So we go to structure, and under model here we have model line. And then we just start to draw. So we can start up here maybe. And in the same way as we did before, we just follow the border or the inner edge of the walls. So around the whole area here, and then up to the top, like that. So yeah, they're a little bit tricky to see now, but if we just do like this, it will, yeah, we'll see them. So now we can start drawing the slabs. So we'll just scroll down so we are on the same page. So this is the area that we should have drawn. So we start the same command, draw slab, and now we just use the pick model lines instead. And just as we hover, now it's very easy to select. So even if they're hard to see, if we just know that we have them here, then we are fine. And when you've gone the whole round, you'll see that you'll get this small minus symbol next to the mouse. Then it means that this one is selected. So if you select it once again, it will be deselected. So when you have selected all the lines, we'll just click finish up in the corner, and we'll get the yeah the boundary like this. And in the same way as before, we are going to start with the support length. So we click this support length and end cap. And in this case, we'll just make it very easy. So we'll have the same end cap on each side, but also support length on each side. So I'll just put support here, and then instead of copy to next, I'll just do the copy to all, so that we have it like this here, and then apply. Then the same, switch to top, -57 as the offset. And then we need to fix the layout, because, or the direction. So we want it standing up like this here. So select direction and zoom in here and get one of the lines. And yeah, I'll do the same so that we see. So zoom out and then pick the lines again. So then this is what we end up with. So we have two small partial end caps. So we need to fix that. So first of all, we pick the insertion, and it's the same here. We try to zoom in on this line. So this is the border, and then this was even more tricky. than the first one, but here we can see this horizontal line instead, which go in here. So this is the new insertion point, and I'll select direction so that I can zoom out and select that one. Then when we have the insertion point, we can see that now we got rid of one of the partial slabs, but we have one that is 150 millimeters or 155, and that's a little bit too small to cast. So I would like to put it on the very right so that we can remove it and then fix it on site instead. So what I will do is use these arrows to get it placed on this side. You see now it's here, and down, if I put it on position 1, it will be here. And then I'll uncheck this insert checkbox. Then it will not be inserted. And then we hit OK, and the slabs will be drawn. So if we go to the 3D here, we can hide these two walls with the hide element. And then we can see that, yeah, we didn't insert this 155 millimeters, so this one will try to fix on site. So we reset, and now it's time to draw the other side. So we'll just continue with that in the same way that we did just now. So we'll just do it with this first. So now all the slabs are in place, and we also see that we forgot to turn on the tool or functionality that deletes all the model lines. So what we can do is just select like this and filter and lines. Okay, and then we just delete the lines. This functionality was here, delete model lines. So if we would have done that, the model lines wouldn't have come. So that's great. We have the whole building created now, and the next step is to draw recesses according to external reference, just as we did with the walls earlier. So we're gonna start the same model. Now we can see that we have this pipe going through. So let's go ahead with that. Um, First of all, in the right side here, under Revit links, where we have the MEP project, uh, right click and use reload. Before we did unload to remove it, but now we reload it back to the model. So we're going to draw some recesses, both from this one, but also from the external reference, like here. So we are going to find the pipe, and the pipe is here in grids. We'll just switch the scale here to 50 maybe, so that we see what we are doing. And we're gonna start with the pipe, and then work on this rectangular one. So with the pipe, it's the same procedure as before. We are maybe zooming in a little bit, going to here and draw recess. We'll use the standard one for circular and specify recess size. And we do 320 millimeters and a cutout. And then hit OK. And now when we go here, we can just place it wherever we want to. Escape. And then we remember that we went to modify, align, and then first took the insertion point of the reference, and then any of the horizontal or vertical, and then do it again. So first reference and then the point of what you're gonna move. So now we have the recess for this one. So we can unload the MEP project again, right click unload, and then if we go to the 3D, we see that we have a recess. So the next step is to do recesses for the remaining or not remaining, but the the references to have here. So these two, the only ones that have a an element. We're gonna do these later. So we are starting the command from model line because we're gonna try another functionality now. So go to structure um, and model line, sorry, and then we can do the rectangle directly, and just make a rectangle like this, something like that. And then we go to draw recess, so impact and components, draw recess. But now instead of doing the standard, we'll use the user defined. So first pick face, so we take the left one first, pick face, so just hover the mouse like this so that you see the border of that slab. Click that once and then pick recess lines. So just make a selection like this, finish. And yeah, here we could use this delete mod lines. And then we do cutout and OK. And the recess will be inserted. And now since we changed the center of gravity and also the weight, we can update the lifters. And then we do the same here. So start draw recess, user defined, pick face, pick lines, finish and cut, update lifts. And now I forgot to delete the model lines. So I'll select them like this, filter. So it's very easy to forget that. And if we check like this, we see that we have 3 recesses now in the model. So now we can see it here as well. And now the next thing is to draw connections. And this is what we saw before. So we are going to insert these from the definition. So we'll start this command and select the 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 yeah the predefined configuration, and then we're gonna draw it in these 2 areas for ones. So just to try it out. So let's start with that. We'll come here and go to level 2, and or actually we can do it in 3D because we don't, yeah, you can do it in a plan or you can do it in 3D. It doesn't, it's a little bit easier to pick the exact point in the plan drawing, but it's more visual here for this training. So draw connection, select the slab, finish, and select the alternative 1, and then insert 2 of them here, and then escape to stop the command, start again, and select this slab, finish, and select the alternative, and do the same. So here I just took some points, of course, but if you want to do it more accurate, do it on a floor plan. So I'll just repeat the steps here on this side. Like that. So now we have connections. Uh, Great. The next thing to do is to draw balconies. First, we need to activate some reference for the balconies as well as clean up the view. So we'll activate the balcony and deactivate the walls and slab. So we'll need to go to the visibility graphics, and now we are on building level 2, building 1. So visibility graphics was view and visibility graphics, or VV. Then we can go to imported categories and uncheck this for art walls and slab, and like this. So make sure that only these 2 are checked. And then hit OK, And what we see now is that yeah, we have some reference for the balconies. And we are gonna start to draw the balconies like here, and we're gonna start with the left one. But to make it a little bit easier to see what to draw or where to draw, because yeah, we have a lot of lines, we'll change the view range again. So we'll go back here, and in the view range edit, we're gonna switch this to 0 and hit OK. So now we can see the boundary a little bit better. We're gonna use the model lines. So we'll start at functionality, going to structure and model line, and just draw here according to the line. So it's a little bit tricky, but just follow the material and it will be correct. Something like that. And yeah, I'll just double check so I didn't put two lines on top of each other. Now I can continue and draw the slab. So we'll go to draw slab command and use the E19. So this is for the balcony. I'll use the top as the placement, and we'll click select boundary and pick model lines. Just select the ones, and when highlighted, we see that they are correct. Finish, and now we have the area. So the support length should be 0 all over the place and 0 end caps. So we can just say copy it all on end caps and copy it all on support length when we have none and 0 and apply. Then the last thing to do is make sure that we have single, so not multiple slabs, but we will just have one slab, and then we hit OK, and the slab will be generated. So if we go to the 3D and rotate here, you can see this. So now it's time to just continue. So I'll do the same on this one. And when I have the model lines, when I've drawn this one and have the model lines, I can also mirror the lines. So I can do it for this now, and then I'll do it for this one later. So just like this, filter and check none lines, and OK. And then use the mirror draw axis, or I could just pick this axis of course as well to do something like that, and the lines will be copied here. So when I've created this one, I will do the same. So now all the slabs are created and we can just select like this, filter, check none, lines, okay, to delete. Again, we could have used the same command, but that is okay. So the next thing to do is to then again reset the view range. So we'll set it to negative 1500. So level 2 view range negative 1500 and okay. So then we see everything like this. So the next thing we're going to do is to apply balcony endcaps because they are a little bit special compared to other slab endcaps. So the top here is sloped so that we get rainwater going away, and then we have some on the bottom side here. So to do that, we need special end caps for the sizes of the slabs. Those are created, so we can just use them, and then later in the course we'll create our own. So what we will do is we will select one of the balconies. We'll start with the left one. So I'll go here and select this one and just go to Edit Slab. And here we see all the sides that can have an end cap. So this side here should have the front end cap, which is called E19 2040 F. And this, and this. So this one, and this one should have the back one. So E19 2040 B. So we'll just click next and set the back one, so this one, and do next until we have this side, and do the back one, do next, front one, and next to get the back one here. And then when we're happy, we click OK. And then updating the lifts. So now we can see that, or we can select it like this. So we have the sloped balcony with the end caps. So we'll continue doing the same on the other ones. Great. And now the balconies are finished. So we will continue with saving the slabs. So we'll select all the slabs because they are on the same, and then save them with the prefix S100, or not the prefix, but the first element mark. So S100, and then for the balconies, we'll save them with E100. So we'll go here, and we can just do like this and select here so that all the slabs inside the building is selected, and then go here and click Save Slab. So it doesn't matter if we have walls or so selected, we'll just look for the slabs. and we'll select the slabs, renumber S100, apply, and then confirm and save. And continue with the balconies. Change to E100 and apply and save. So now we're done with the slabs and the balconies, and the next thing to do is the hollow cores. So for the hollow cores, we'll do the same procedure as for the element types we have gone through until now. So we'll click on this, click to get started, and we start with the definitions. And the hollow core definitions are quite, yeah, quite big and a lot of details to work with. So we'll go through every step of it, so we know how to create a new one. So we can go to the hollow cores, and here in the project we have the definition 19, so we can click edit. So the hollow cores works a little bit differently, and it's because it's a quite complex geometry, and the geometry is not like a beam or column where you have just the shape of the cross section and you decide the measurements. But the sides here and the cores are, yeah, they are differing a lot between the manufacturers of the hollow core lines. So instead of having the option to, or yeah, basically we have two options to generate or create a definition for hollow cores. The first one is if you have a family already, a structural framing family, then you can just load the family and read the data from it. Or we have the option to create this cross section and generate the family, as we did for the user-defined columns and beams. So we have no option to select the type of cross section, enter measurements and so on. And I have a, or we have a good guide here in the, I'll close this one or minimize it. So we have a good guide here in the definitions. So this is what we aim to have as the reference, or not, yeah, to be able to create the section basically. And it's the actual lines for the border for the course, and then for the zones. So here the vertical lines are just showing the different cut zones, as well as the symbols here shows us the position of the strands. So this is what we need to have. So usually you can get or create this by importing a DVG from the manufacturer of the Holcor line, uh, put some or draw some lines on top of it and prepare that way. And then when we have it, we'll of course go into the definitions and click on this pick section. And the first thing to do is just as shown here in the GIF, to click all the boundary lines just one by one, so that we end up with something like this here. And from this, we'll get the height, the width, and also all the geometry. This here on the right side, we don't need to do anything about. It's more to yeah, to see that if something is wrong, we can figure out what went wrong. Then we have some things to set up, and the first one here is the tolerance. So normally we talk about the hollow core that is 1200 millimeters, but the actual slab is only 1196, and that's because we want to have some tolerance on the sides. So 2 millimeters in each side is one normal case. Then we have this difference from bottom to top, so this to this, and that's used in later on in the production software. So it's just we'll just need to measure that distance, and then we don't need to do anything more about it. And then before we can create the family, we need to set up the material. So what type of concrete we should have, as well as if we want to have the production mold. So you remember this limitations of size and mass. And then after that, we can click on the create family, and Impact will generate the family. And here in the end caps, we can also, as we did for the slab, have a predefined end cap, and this one will be for the short sides, because we don't have a end cap on the long sides here because we have this profile. So that's the first page, and then we go to the second page, which is the course. So we can follow here as well. And it's basically the same procedure. You select the course one by one, and in between the selecting the lines here, you cannot see it here in the screen, but you go up in the top left corner and click finish, so that we separate, for instance, the first and the second core, and then we end up with something like that. And we also have the possibility to use this show core extents. So in this case here, or in this example, it might be a little bit unnecessary because the cores are complete circles, so it's quite easy to see, the boundaries of it. But a lot of cores are like in non-symmetric geometry. So to give or have a good understanding on the boundary of the core, we have this functionality. So this won't do anything with the actual slab, but it will just give us the information visually. So the next part is then sorry, I was a little bit quick here. We cannot click on this create before we have the cores, because the cores are also in the family. So after we have created or made the course, then we can go back to the general tab and click on create family, because then we will generate the family with the course as well. If we would have done it up here, it would mean that we just get the slab without the course. Then we do the cutting. So basically, we can just wait for this GIF to restart. So basically what we do is select cut zones, select the insertion point, which is always lower left corner of the element, so this point. And then we just click through all the zones here. So the zones or the where we are going to cut is going to be in the cores because we cannot cut in the strands. And when that's done, we'll end up with something like this. And yeah, where these red crosses are, it's where we can perform the cut. So in between, it's not possible. So the first thing we need to do is to set up, or not set up, but decide if we're gonna cut from left side, so that the right side is yeah, used, or you're gonna cut on so that on right, so the left side is used, or symmetrical, so we're gonna cut on both sides. Normally it's left or right because you don't want to cut 2 times if it's not necessary, but sometimes you need to. Then this setting, use nearest cut zone when cutting elements, is also necessary to have, because then that one will prevent, or will make sure that the cutting is done in the cut zones. Sometimes in some special cases, like you don't want impact to the side, so sometimes it's fine to cut here in where the strands are. If that's the case, then just uncheck it, but in most cases, this one needs to be checked. And yeah, if you don't have the marks here, you can also add the cut zones manually by setting a start and an end X value. So start X value is here, and then end X value is here. Then the next part is to select the strand positions. So in the similar way as we did for cut zones, we just pick strands and just pick the uh, the positions basically. And then we end up with something like this. And first, everything will be in the same group, but then we can divide into different strand groups. So these strand groups could be used for different tensions or also so on. So here I have two or three, sorry. I have inner bottom, so it's these ones here, and then I have inner top, which is these ones, and then I have outer bottom, so it's this and this. So then you just click through this this list and assign the group, which is what basically. And with that, you can then later on create, or in the second or next step, create strand patterns. So a strand pattern is basically options of what strands to use for specific situations. So in this case, my strand pattern number 4 is the default one, so it will come automatically when I draw this hollow core. And this will just have this, 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 and this strand active. So I'll only get, or I will get 4 strands in this element. And they will have a diameter of 12.5, 7 wire inequality, and 120 in pre-stress value. So here you build up the standard of all the positions or combinations you can use, and yeah, this one will be decided when you draw and edit. So we'll look at that in a minute, or in the next step when we draw the slabs. Then we need some lifting, and normally we are lifting, or the slabs are lifted like this on site with these clamps, and this is also why we have this profile. But sometimes for cut elements, for instance, then we cannot use the clamp. So in that case, we will need to insert cast materials. So it basically, if we skip the first one here, it basically works as for the slabs. We have the rotation, and we have two options, either 2 or 4 lift points. So we have this setting deciding what should be the when we should have 2 and when we should have 4. And then we also have the types for the for instance, for the lifting angles. And then you build up your list of cast material. So here I only have one. And then the placing on long side, we have 3 different options. So this exactly the same as in the slabs. So fixed distance from the edge, part of length, center of gravity. But then for the um, placing short side, we have 4 options. So we have the same as above, so part or fixed distance, part of width, and center of gravity. But then we also have the option with center of core, and that's often used for the hollow cores. So it's these ones here. And when you use the center of core, you would probably need to have a core filling, so concrete filling out around the lifter, so that the slab can handle or that the slab cannot don't break when you lift it. So then you have some setting if with visibility and dimension, and then also the length of the core filling. So if I have 600 here, it will be that the lifter is placed in the middle, and then 300 of each on each side will be filled of concrete. And then we put what cores that the lifter should be placed in. So in this case, it's number 2 and number 7. So this is the setup. And since I skipped this one first, I think it's good to talk about it now. So since we have these clamps, we don't want lifters in all slabs. So or for the slabs, for instance, or for the walls, we want the lifters in each element. But here we only want it in the cut elements. So we have 2 options. So we have automatic or manual adding lifters. So adding or saying automatic will place lifters in all slabs or hollow core slabs, but manual will place it in no slabs. But instead you as a user can apply or trigger the application of lifters, so that it just comes in the ones that you need it for. Then the naming dialog, it's the same. So just the, the values are differing. Um, Then we have 3 more tabs. So you can see here for the hollow cores, it's a lot of tabs for the definition. And the first one is called recess, and that's a way to automatically add recesses for connecting slabs. And this one is connecting slabs together, so the one slab to another. So we can take a look at the functionality here. So we have this, either you have none setup or circular and circular, which means that we have a circular recess throughout the width here, as we see. And then you have 2 places or actually you can decide here with the cores, but you can from top enter the or having a recess so that you can enter the core and make the connections basically. Then we have the recess edge, and that's more used to connect the slabs to the walls or other structure. And here we have 3 options. So first one is just a rectangular offset or a recess like this. Then we have the rectangular and rectangular, which makes this sort of hammer. So we can see the cross sections and you decide the values, of course. And then the one that we are using in this example, it's this rectangular and circular, which will add a rectangular recess on top here. So the corner will be or the side will be open, and then it's connecting to this the next core, and we'll have like an access from top of the element. So yeah, these ones are just prepared here, and then they are placed with a functionality that we'll take a look at. So we can, these two we can, if we're gonna compare it or so, it's very similar to the connections in the slab that we just saw. And then the last one is configuration of weep holes. So yeah, to drain the water that might come into the slabs. So in the top here we have the general weep holes, which is basically, yeah, we have how or what type of hole. So we have squares and circles, and you can either do top, bottom, or a hole that goes through the element. Then you have diameter size or side size of the square, the offset, and then the offset if you have a long element. So here the B value needs to be yeah, it needs to be at least 2 meters. Then if we have a recess, we need to do or we can have the option to add the weep holes in a special way. So in this case, we have yeah, on each side we can decide how to place the recesses and if and so on, and the same around core fillings. So it's yeah, different but the same. And then we can also have a tolerance here. So let's say that we have an element that has a complex geometry and yeah, a lot of recesses and so on, so that the weep holes are placed close to each other. Then this one will make sure that we cannot add the recesses closer than 400 millimeters. So if that's the case, then we'll remove one of them. So this is the definition of hollow cores. So with this guide, you should be able to create your own configurations. But we can just close this and go back to the material, and we are next going to draw the hollow cores. And as we could have probably yeah, known, is that we have two areas left, because here we have the slabs, of course. So in these two areas, we'll draw the hollow cores. And yeah, now since we stopped, or the last thing we did was to draw the balconies, we need to switch the external reference before we can start. So we'll go back and open level 2 and zoom in, because here you can see that I don't have my recesses, for instance, here, like the shaft and the recesses. So I don't know where to do it. So either we access it with the view visibility graphics or VV. Go to imported categories and turn off balcony and turn on walls and slabs, because then we are getting the recess that we need. So we'll just start the command to draw, and we can find it under the hollow core commands, draw hollow core. Make sure that the project and project definition 19 is selected, and the next step is just to select the boundary. And the boundaries are the same as for the slabs. So we have done model lines, we have done pick points. This pick point enclosed area and pick floor is a little bit special, so we skip those now. But the last option that we haven't used yet is draw rectangle. So that works well in our case here. So we start that one and we start with the left area. So we zoom in the top left corner and then top or bottom right corner. So like that. And yeah, when you have a rectangular area like this is absolutely the quickest way to do this. Then we need to select the direction because it's unnecessarily long here. So we click the select direction, similar to the when we did the slabs. The next thing to do is to adjust the slabs because we can take a look at the area here. So we see that you have one, or actually we have two cut elements, the one small here as well. But then we also see that this here, this shaft, is yeah, is not aligning with the slab. And normally it might not be that it's you know it's the same here, like the same this size, but in our case it actually is. So the shaft and the width of the slab is exactly the same. So it's just to make it easy for us. So a good idea would be to align this slab to the shaft because then we just need to cut one element later on. So that's what I'm gonna do, and I'll use the pick insertion and just select this point here. Because what happens now is that we align it, and yeah, we can select the direction and as well. And now we can, yeah, we have a good view of the elements. So the next thing to do is to do the support length. So we can click that. And we are going to add the 80 millimeters on these two sides, which is already done. So we can hit apply on that one. Also, as for the solid slabs, we changed the placement and elevation offset. So we'll just switch to top and negative 57 millimeters. So now they are there. Then we can switch to the end cap or tab and configure end caps. And it actually is the U2 that we're going to use, but we need to just load it because they are not loaded correctly here. So just switch between the two. And these ones will add yeah, first this kind of profile, but then it will add a slits of 700 millimeters. So then we can go back and click general, and the last thing we can do is to take a look at the strand patterns. So remember from the definition that the strand pattern we had was 4, the default one, but here I also have other strand patterns that I can use, and we'll see the result here as well as the information about the, the pattern here. So with that said, we just hit OK, and the elements will be drawn. So this is what we end up with, and we can continue do the same on the right side. So yeah, maybe not from 3D, but here. So exactly the same as we just did. And what we can see here, that here we don't have the shaft, so we don't need to align it in a special way. So we can just align it in the inner face of this wall here. So both are now done. So the next step, if we check the bottom here, is to add a hanger. And the hanger is basically used for this, this situation here we have with the shaft. So since we are cutting the whole element width, we cannot support the element on this wall. So instead of that, we'll insert a hanger, which is like a steel beam that will support. And to do that, we need to we need to set up this thing. So we start the command insert hanger, which is here, and we'll do this on plan. So we have this insert hanger, and here in the prompt, if we are not selecting anything, like we have here in the white space, so in the prompt in the lower left corner, we say it says select slabs to support. So if this shaft would be on 2 slabs, we could select 2 slabs, but now it's only this one that needs support. So we click that and say finish. And it says now select supporting slabs. So it's the one or the 2 around it that will support the middle one. So this one and this one, and finish. Then it tells us to specify first corner. So we'll just zoom in here and take this corner according to the blue reference. And then second corner, which is this one. And then we'll select our hanger detail and hit OK. And this is what will happen, that we will get this sort of connection. Then this one can be deleted if that's still there. This is some rest of this recess. So it's quite easy, and additional to the course material, if we have a shaft in between here, so if the shaft would be here, we could do the same, use this command the same, just the first corner we pick is here and then here. Then we'll have 2 of these steel beams. So that's how this works. And the next thing is to draw some recess. And we see that we have 3 or 4 recesses, 3 rectangular or squares, and then we have 1 circle. So we will do that by the same approach as we did for the slabs, solid slabs, and that's drawing model lines first. So I'll go to my level 2, and we will start structure and then model line, and I'll start with the rectangles. So yeah, zoom in as long as you can to find the reference. Oh. And if you, as me, I clicked here so that it's wrong, then just hit escape once to get out of the command. And then we have this one. And then up here we have the circle. So then we need to switch to circle. Something like that. And then we start the command. So we start here in modifiers, draw recess, user defined, and pick face. And we start with this one maybe. And now it's a little bit tricky to find the face because the cores are easily to be selected. But just make sure that you are in a place where you see, yeah, the border of the slab like this. And then pick recess lines like this. And yeah, here we see the results. So the face is selected and 4 lines are selected, which is exactly what we are looking for. And then we do the cutout and hit OK. And we don't have a lift, so we'll just keep the change here, and the same here, or we'll continue here basically. So pick face, pick lines. And what we didn't do before was deleting model lines that we can do now, and cut out and keep the settings. Then here we'll do the same, but now we'll use the reference in 2 slabs. So we'll start with the draw recess, user defined, pick face, and take 1 of the lines first. We'll take this one and pick recess lines. But here, instead of deleting the lines, we'll just keep them and delete them when we do it on the right side. So cut out and OK. And keep lifters. And then we do the same, draw recess, user defined recess lines, cut out, and now we can delete the model lines. And since we used the same reference, there were 2 slabs or 2 on the same place, but we can just say OK on that. And then we do the last one in the same manner. So draw recess, user defined. So this one is what we talk about. So keep. And yeah, now forgot to delete the model lines, but I'll do like this, and I also forgot it here. So I'll just select the lines and delete. And yeah, this is what we end up with. So the next part of the training will be adding core fillings manually. So that is what we're gonna do next. So these two slabs or hollow cores that we made in the middle of the building, let's say, where we added the recess, they are not as strong here around the recess as we are cutting this piece out. So to make sure that we or the capacity of the slab is maintained, we'll add core fillings in these slabs. So we'll start on the left side and yeah, on the level 2, of course. So start here, and we'll go into the hollow core settings and use the core filling command. Then we have this in the lower left corner, the prompt. So select hollow cores to insert core fill, and then pick points. So we're just gonna pick or have it around the first opening or first core. So we can just make something like this. And this, yeah, this area that I'm picking is just to, yeah, select this this that we got here. So we could have also just selected everything or just selected a little bit. We can also configure everything in the afterwards. But what we are gonna keep is the core number 3 and the core number 6. So 4 and 5 in my selection will be deleted. And we're gonna make the length 800 millimeters. And then say OK, and we'll get this and also save. So then we do the same here. So core filling, or we can start command from here. Select the slab and then select here. I'll just redo it and show you another. So if I would just take it from here to here, I'll have the same, but just all the cores selected. So now the difference is that I just need to delete more of them. So we'll keep the same. But now we can see that the start at is not 0. And the reason for that is that we are having yeah, the length of the slab or the insertion of the slab is not this side but the other side. So now we need to do some calculations, or we can check in the material. So we'll add 406 millimeters here, which will result in that this will be 3,880, where the start is going to be. And then 800 here, like this. And say OK, and we'll end up with this here. And now we can also see that we are getting this one and this one, and that's these slits. So that is the next thing we're gonna do in the material, in training material. So edit hollow core. So you see here that is also probably more visible in the 3D, like this. And yeah, the reason for that we're getting this is that we have the setting that we will have this in the end cap. So we'll remove that. So we need to do it on one each, because this side, since we started with this with the core filling, we had the the yeah the start at 0, which means that this is the insertion side, which is left side, and this is right side on this one. So if we would edit both and say that, okay, remove the recess, then we remove the recess on this and this side as well, because we're gonna remove it on left side on this, but left side on this one is this side. So we do it on one each. So select the slab and edit hollow core. And the thing we need to do is go to Endcap and just switch from U2 to U1, because U1 is just a profile without any cut. And now that one is gone. And then the same here, edit, and change the right side now to U1. And okay. So now it looks good again. The next thing to do, or we can actually continue. So the next thing to do is to add lifters, and it's for these slabs that we placed that are not full width, and we can again not lift them with these clamps. So we'll add the lifters with the command here, so we can be on level 2, sorry, maybe. And on this side, it's this that we need to add lifters on, and the lifters can be found in the components area under not custom draw custom material, but under custom material, and insert update lift and hit insert. The lifters will come and do the same on this side. So the cut element is here, repeat, insert, and click there. So now we have lifters in both the partial slabs. The next thing is to draw V-poles. So that's a very easy process. So we'll just select or start the command and select the slabs. So we can do it from here maybe. Go and in the bottom we have draw V-poles. Select like this here, so that all hollow cores are selected, and finish. And now the holes will be inserted, as we can see here. And depending on the slab, it will be different. Great. So now all elements have the V-poles, as we can see. So the next thing to do is the last thing we're going to do when modeling the hollow cores is saving. So in the same way as before, we'll name this one, the first one H100, HC100. So you can probably be here in this view if you want to. Select it and save hollow cores. So select everyone and HC100. So it's time to save, and here we can also see that in the hollow cores we have a better or higher, um, or it's more often that we have identical elements. So you see here that we have 5 of these. So then 5 of the elements should have the same element mark. So great. So now we have almost the whole building done with the modeling. The only part we have left is this staircase. So that's our next topic. So we can start the linked elements, which is the element type we're gonna use for the staircase. So the linked elements is basically an element that is not any of the standard element types, like column, beams, sandwich walls, double wall, and so on. So this could be anything, and in our case, it's a stair. So since it could be anything, it works a little bit different. You don't have a definition that sets the size of the or the shape of the element, but you use the the families for it. So we're gonna start with this, and we'll go to level 1 because we're gonna place the stairs on level 1 in this middle here. So we can go to the functionality draw linked elements. So up here, and in the top we can select the definition, um, which is called yeah, it's basically the size of the stair. And with that we will get some product, some designation, and some element mark, and so on. So the thing we will do is set the size. So we will put the length to 1750, the width to 1000, the height to 1170, and then the gross area. Um, then you take the area like this, so it's from the top, so 1.75, and that's the same for all because we don't have any irregular shape. Then we can calculate, or sorry, we'll need to add the volume 0.57. So all these values are coming from here. So that's why we get them, and then we can calculate the mass and the weight of the element. Then we click OK, and we can place the stairs. And yeah, it's a little bit tricky to place them 100% correct. So just place one of them, and then place the other one on the other side. And we can rotate um, the other stair so that it goes that direction, because we'll see that soon that these two stairs will meet each other. And you do that by just using the space key on the keyboard 2 times, then it's rotated. And then we can escape, and we select one of the stairs, use the move command, just this corner, and then it's the green line and the center line here, to that point. And we do the same here, so that we have it like this. And now we have the element placed in the here basically, but we need to of course have them placed in vertical direction as well. So they're fine in plan now. So we already have a section that we can use. It's this section that we used for recesses in this wall here. So the first we can do is just select the section and just drag it like this. So select it so that it's blue when you see the dashed lines, and then drag it so that we have something like this. And we can expand so we see this part here as well. And then maybe we don't want to see too much, so we can just make it a little bit smaller. So this is the area we'll see, and then either right click and go sorry, need to select the section again, right click, go to view, or we can double click here in the project browser on the sections. So plus and section and double click. And now I placed it a little bit wrong, so we'll go back because we need to place it in here. So otherwise we'll get this wall in the way. So this is much better. So now we can see the stairs. So this one, the first one, and if I select it, it's also selected there. We'll go this direction, and then we'll create a landing page, landing slab, and then this one will go up here. So that's the starting point, and we the first thing is just to select this wall that should start up here and change the elevation. And the elevation is this elevation from level up here in properties, and from the course material we have um, the, the the length or the elevation 1180. So we can just put it like that, and this is the result. So now the stairs are pretty much created, and we need to draw the slab on that will be the landing. So I'll go back to my level 1 and start the draw slab just as we had before. Select the SS19 and we'll draw it with select boundary and draw a rectangle. So from here down, zoom in here to this point. And first of all, we'll make sure that we don't or that we have don't have the support length. So we'll click support length here, and or actually we should have the support length, but not on this side. And on this side we shouldn't have the end cap either. So here we'll just set no, and then we'll go to, because this one and this one and this one have the correct end cap, but this one doesn't have the support. So we can do like this and just copy to next. So this is, these three sides should be the same, and this shouldn't have support length nor the end cap. So you hit apply, and it should be insertion top, and the elevation should be 1170. And then we can hit OK. So it won't be visible here because it's in the middle of the elevation. But if you go to the section, you see that we have it inserted, and if you go to the 3D, it's also visible here. So that's great. Then we're gonna draw the slabs on top here, so then we can go to level 2 and draw the rest of the slabs here. And that we just do in the same way. So we start draw slab, select boundary, so draw rectangle, and then we can do it from up here maybe, and down here. This one, yes. Then we go to the support length and end caps and make sure that it looks, yeah, like this here. So we'll have the no support length on the short sides. And then say apply, we'll have placement top and negative 57 millimeters of offset. And then we can hit OK again. And the slabs will be created. So we can go to the 3D to check again. And now it looks like a complete building. So we can access the top floor as well. So the next step, so now we went through all these steps here with decorating the stairs, changing the elevation, drawing landing, and draw the slabs. So the next part is to save. And we can start with the two stairs. We go to here again, and yeah, we can be in any view. So we just need to select the stairs, go and click Save Linked Elements, and again renumber so that it's starts at a number 100. So like that, and save. And then we select our slabs, so the landing and the slabs, and save slab. And these we don't need to change the names because we have saved slabs before, so they would be in the 100 series. So we click save there, and now the model is basically done. So we'll go to the material here. As we can see, the next is edit model. So if I go to the course material, so to get the overview. So now we have done the whole modeling part. So we have gone through the functionalities for yeah, basically the modeling step. Then we have the next chapter, which is the edit model. So see, even if we went through how to model the whole building, there are some commands that we didn't check because they are more in yeah, in the modeling or edit than into the draw the model. So that's what we're gonna focus on now. And the first thing we're gonna do is edit walls, and that on those elements we'll edit some openings and draw some panel thickenings. So let's start with that. Yes, so the first edit we're gonna do is to update or change a window, because yeah, that one is gonna be changed to a door, because the only access that we have to the building is actually through the balconies. So we need to enter the staircase somehow. So this one will change to a door, and that we'll do in 2 steps. So first we need to remove this window, and then we'll update some references so we know what to place, and then we'll place the new one. So I'll go here and change or start the command edit opening. So under wall commands, and I'll select my window and say finish up here, and then basically just delete. And what will happen now is that I'll get a question if I want to update the lifts, and I can say update on this because we'll get a new door in a second, but we can just update anyways. So now the element is done, so we don't have the window anymore. And the next step is to add the, some reference on level 1. So if I go to level 1 and go to this side here, it still says that it's going to be the window F3, and that's because of that it's our old reference basically. So what we'll do is we'll first of all link. So we can go here to insert and link CAD, and we are going to link the from the project folder again. And again, the easiest way is just go to project manager and right click on drawings, open folder, and then click here, copy, close this one, and go back to Revit and paste and enter. Then in common drawings, we'll find a DVG called level 1 arch xref wall slabs revision DVG. So select that one and change the input units to millimeters, and then open. And then we see that we have something more. We have this revision cloud and also some more text, but we cannot see what it is. So first, before we can read it, we'll just turn off the other or the old reference. So either we go here and visibility graphics or VV, imported categories, and then turn off the first one, which is the level 1 architecture. So we can actually turn off so that we only see the level 1 joints and level 1 architecture revision. So all level 2s, even if we don't see them, we can just turn it off and hit OK. So now we can see that it's the door D1 that will be inserted here. So we'll draw that one. So go to impact, and instead of edit opening, we go to draw opening, switch to sandwich walls, and then we have the D1. So we hit OK and just place it. And then now again, we also changed the mass and the center of gravity, so it asks to update, and that's something we want to do. And then we can escape 2 times to terminate the command, and also then apply the door on the wall. So something like that. And if we go to the 3D, we see now that we have the door instead. Also, we can go to the same here and turn off this reference so we don't see that in the 3D. So that's the first edit. So that's how you edit openings. And the next part is to add some panel thickenings to strengthen the wall here, because it's a very small wall, and the sides here are not that wide. So we need to add some more concrete to make sure that the strength is in the wall. So we'll click on this draw panel thickening, and we need to prepare the view first. So we have the section 1 already, but we'll create a new one that is in this direction, because section 1 is a vertical one, and that's so we have two sections to use. So we can go to the plan drawing again for level 1 and create a section either from here, from the quick tools, or view and section. And then if you do like I did here, left to right, then we'll point up. If you do right to left, it will point down. But I will do it like this and just use the flip arrows here, something like that. And then places something looking like that. Then we'll need to go to the section. So right click and go to view, or double click on here in the product browser. And now we don't see that much. So first of all, we can select this section and adjust it so that we see um, the first or the element here. We also see that the mesh and so on is in the middle, so that will need to be updated, but we can fix that a little bit later. We'll switch the scale to 1 to 20, so that it's a little bit smaller. We'll put the visual or visibility to wireframe, and also the detail level to fine. Then we'll also go into the visibility graphics again, so VV or view visibility graphics, and turn off the reinforcement. So you can click on the S on the keyboard to scroll down and turn off structural fabric areas, structural fabric reinforcement, and structural rebar, and OK. So now it will be a little bit more clean and easy to work with. And we are going to add the panel thickenings around here. Also, one more thing that we're going to do is to change the parts visibility. So now we are showing the original element. So this means that we don't see end caps and so on. So we'll show parts instead, which allows us to do this. And we're going to add some panel thickenings on here and here to strengthen the element. So basically, what we're gonna do is start the command, and that's on under the walls, so where we had drawing openings. Then a little bit down we have panel thickening. So in the prompt down here it says please select wall. So this is our wall, and then we need to select how to put it, and or how to insert it. And I want the panel thickening to be on the outer panel and on the inside of it. So it should not be outside the faces. And then the size will decide, but the depth or the thickness will be 50 millimeters. So that's the first step. Then to place it, I'll use this lower left connection or location first to put the first point. So we'll go here, and here we see the dashed line that is the grids. So we can just click on this one to get the first point, and then we click on this one to get the second point. So it's going to be this up here. So now we have the correct placement, and then we hit OK, and we'll place the panel thickening like you see. So it's this line here that's added. I don't have it here. So we'll do it the same on this side. So start the tool again, select the wall, and put 50 millimeters and out the panel inside. Pick point. So first this point here, or we can actually do no, we do this point, and then pick, and then just use the reference here, so that one, and hit OK, and this one will be inserted. So now the panel thickenings is added, and we can just, if we scroll down here or turn down here, we see that we have entered this panel thickening so that this wall is a little bit more stable. And now we need to save, and we can also have a good opportunity to check here update status. So if I scroll around, I see that this one is needs to be updated. What I also can see is that we need to update the element so that the mesh is correct. So to do that, we just say apply RC template again. And for sandwich, okay, select this wall and finish. And now it's updated according to the door. So now we can save. We can select this one and hit save slab, save wall, sorry. And just save. Yes. So now everything is closed or saved. Everything is gray. You can close this one, and yeah, this is the first edit. So we'll just continue with the edit beam, and we remember that when we drew the beam and the column, we had a socket in the corbel and also this fixture recess in the beam. And we didn't check, but they are not aligning. So we can just go to Revit and maybe maybe we can be here in the 3D and rotate so that we are on this side here. So we can now see here that, okay, that if I put my mouse here, we can see that this here is the um, the sleeve, and this hole is wrong. So we need to edit this and or the placement. So first, maybe we can go to the level 2 to measure what we need to do, and maybe we'll move this one too close to the edge. Maybe you would not do that in reality, but in this case we'll just do it. So we'll just use this tool here that is like the measure tool. It's also in the annotate. Sorry, it's not there. It's or actually it might only be up here. So measure between two references. So find the center point or midpoint of the recess and the midpoint of the cast material. So it's 80 millimeters. So we'll move these 80 millimeters. So we'll select slab or the beam and go to impact, and under draw beam we have edit beam. And then we go to end, and here is where we were before. So we'll switch or remove 80 millimeters, which leaves us with 80, and hit apply. And now we have a good alignment. So again, maybe a little bit too close to the side, but it's just for training purposes. So it's just how we know, so we know how to do it. So that one is correct. So we'll save the beam now again, so that everything is up to date. And the next step is to copy elements. So we have seen, or maybe we haven't, but as it might be that you've seen that we have the columns and beams on this side, but nothing on this side, which means that, yeah, we need to fill this space because these slabs are now floating in there. And to do that, we cannot use the copy command in Revit, copy or move, because then we are losing some information that is not visible information, but it's more for the database and for Revit to work correctly. So we have another command or functionality called copy move elements, and that is what we're gonna use for this step. So we can make sure that we are on level 1. So I'll close this one first. Level 1 here, and we'll start this tool, and this tool can be found here in this tool area. So top right, if you drop down, we have copy move elements. So we'll select both columns. So it's a lot here, so maybe zoom in and find it. If you cannot find it, you can use the tab tool or tab key on the keyboard, and then the beam. So it should be column, beam, and this column as well. So you can see that it's selected because I have the minus next to the mouse. If I do here, I have plus. So I have my selection, and I hit finish. So this is the command. So we'll see down here that we have 3 elements selected, which is correct. And we have some options here. So first is our default is move element, and that's not what we want to do because we want to copy the elements. Then we have moved to level. It's like switching from level 1 to level 2. Then it's copy elements that we're going to use, and then we can also copy to another floor. So that's just how we do with the references and so on. But we're going to copy elements, and we're going to do it with picking points. So we're going to do select a base point on both sides. So I'll click pick points, and a good idea is to pick something on the reference. So here in the columns, if even if I have my custom material and so on, so or a custom material in the corners like the column foots. So here it's the reference for the column from the external reference DVG. So I'll click on that one as a base point, and then zoom out and go to, so it was this this column, the left column, and on lower right corner, so this one. So I'll just zoom in on that one and use the same point, and now the elements are copied. And we can hit escape one time to go back, and then hit OK to make this change. And then we get a warning from Revit. So this is nothing with impact, but it's just telling us that a new assembly type was created. So it was one of the elements here, or actually all of them. So this is what we get. And now we need to save these elements. So we'll go here and select first the beam and save that one. And here it says, okay, do you want to keep the existing mark? Because now we have copied, but while copying it, we changed some positions, I think, of something. So we'll just click on new mark here. And okay, so this is just Revit, B101, that's perfect. And do the same for the columns. Great. So now we have everything saved and the elements are on both sides. So the next thing we're gonna take a look at is edit boundary, and this is now in the edit slab part. So here we're gonna continue. So the edit boundary is going to be used for editing the boundary of the slabs. So in this case, we'll practice with a revision as we did for the walls. So we'll load a new revision. So we'll go to the project and to level 2, and we'll go to the insert link CAD, and if we don't come to the common drawings directly, we go to the project manager, right click on drawings, open folder, and copy the folder as we did before, and then paste it in the file name, enter, and we come to this page, and then we go to the common drawings. So we'll select the level 2 architectural X reference for walls and slabs revision. Switch to millimeters and hit open. And now we see what is happening here. So this one is changed. So the wall or the slab is actually going here while we are having the border here. So we're gonna fix that with the functionality for editing boundaries. So the first thing we need to do is to deactivate the thin lines command. So before we start anything, we can click or go up here to this symbol, thin lines, and deactivate it. Then all the lines will be much bigger, as we can see here. That's not really preferred when you work with the modeling, because it's very even if we have thin lines, it's a little bit tricky to see what's what here, but with these lines you cannot see anything. So these I just use when we have something like a situation like this here, basically. So we go to impact, and underneath the save slabs, we have edit boundary. So we start that one, and we will, in the prompt here, if I put my mouse on the white space, it says please select floor. So I'll select here, and then I get a message saying that please use impact sketch lines line style to update the profile. And I can say do not show this again, or I can just keep it so that every time I start it, that it will pop up. And this means basically that the line style for this it needs to be impact sketch lines, because we are looking for that line style when we are modifying here. And if you use another line style, we'll not be able to recognize it. So then you just fix the lines. So first we need to adjust the length of them. So we'll use the tab here until we select the line. So you see here that it's a lot of things that are selected before the line, but now I have it, so I can just click it. And then I get this small blue point where I can drag the line. So I'll just do it like here maybe. And then I'll do the same for this one, like that, and drag it down here. Then we need to make some extra lines, and you can do that by going to structure and model line. And here, before we start, we need to switch to impact sketch line, and then basically just draw the lines. And there are so many different ways to do it. One way is to just do it a little bit longer here. Now I have the chain in active, or not inactive, but I have the chain active, so it will just continue. So I'll just escape once, and then it's a little bit tricky to see, but I get a small square around the endpoint here. So that means that I am selecting the correct point, and I do the same here. Then try to select these lines again and cross them like this, and then I can go to modify and use the trim command to make sure that they are connecting. So this and this, this and this. So this is what I'm looking for. And when I'm happy and I'm sure that they are connected, then I'll go to impact again. And then in the right of here, we have the checkbox to say OK or cancel the operation. So I'll say OK. And I get the information that a new assembly was created, and it was because we are changing this one. So it's fine. We say OK. And then the previous one was deleted, so it's fine. This is just Revit stuff. And there we go. We have it. And this edit here was not big enough to cause the update of the lifters. So it's that's why we didn't get the question. But now when we're done with that, we can activate thin lines again to get it a little bit easier to read the drawing or the view. And if we go to the 3D here, first of all, go visibility graphics, so view visibility graphics or VV, imported, and turn off the new import. But then we can also see here from this that we have the edited or the edited slab boundary. So we'll also fix the end caps so they look okay. So we can go edit the slab, select the slab here, and finish. And then I'll the end caps are reset because of the edits because we have changed the profile here. So we'll make sure that all sides or this side and this side has 3001, and this one as well. This one has the 1001. So 3001 here. Next, this one should have 1001, 3001, and none here, and then 3001. And then we can update lift because now we went over the limits for updating, and we end up with the edited slab. So we'll finish off with saving. So select and save slab, and hit save. Perfect. So the next thing, if we scroll down, is actually our next chapter. So it's create components and definitions. So it's chapter 5. So we'll go through Endcaps, joint, MEP-Keys, Rebar templates, and custom materials. And this is basically a chapter where we're going to create things that we have used here in the modeling part. So yeah, that's going to be the next. So we're just going to start with the end caps. We can click here to get started. So we're going to start with an end cap for sandwich, and then we're going to do one for the balcony. So for the sandwich, we'll go through the concept of end caps, and then for the balcony, we'll do the special things that is for the balcony, because that's the, like, all end caps are pretty much the same. It's just if it's for a wall, if it's 1, 2, or 3 layers. But for the balcony, it's a little bit specific that we'll take a look at later. But before we can start with end cap, we need to prepare the geometry. So this is usually done in a legend view. So like here is a picture, and we have 2 parts. So the first part is the lines that we're going to use for creating the information in the database. And number 2 here is for creating a detail that will be placed on the shop drawing. So this one is called level 1, and this one is called level 2, or level of detail 2. And to organize all your end caps and also be able to, in the future change or create a new end cap by copying and changing some values, then it's recommended to create like these sort of tables in the project template. In that way, when you create a new project, you will always have this available. Then there are some rules for the end caps. So the first rule is for all end caps, and that's that the inner or the insertion point is always lower left corner. And that's something that we recognize from the previous task we have done in this course. So in this case, this point here, so it's from the original wall. The second thing is that the elevation or the end cap or the element should continue from left to right. So here we see that it's the end of the wall in this case, and it continues this direction as this arrow. Then the second rule is for the for the sandwich walls and also insulated walls, and that is that the inner panel should be down. So here we have the inner panel, so that should be down. If we do it the other way around, it will not. We cannot recognize this end cap for this type of wall. And what to or in these two, level 1 that we have here and level 2 that we have here. In level 1, we can use detail lines, we can use dimensions, text, fill regions. So basically what we can see here. But then in the level of detail 2, we only use detail lines, and we should create them so that we have each part available. So we have first the outer geometry, then the layer boundary, and then the reinforcement boundary. So this is what we're gonna create in this exercise. And just a note here, maybe it's a little bit complex to understand it right now, but you see here in the outer geometry that we have this same lines here. It's just that they are different colors. So in reality, I could use this line and this line both for the outer geometry, but also for the reinforcement boundary. But in this exercise, we'll do it more clear, so then we have two sets. Also, the reinforcement boundary, that might not be something that is obvious where it is, but it's a functionality to control where the automatic reinforcement for an example or reinforcement templates will stop. So for instance, when we have yeah, the original wall will be like this here, but instead of or here maybe we can say, so instead of the mesh going here until the cover of the original wall, we'll just stop it here where we apply the cover from this reinforcement boundary. So that's the theory about around it, and we'll just practice. And in our project, we have um, this end cap that has this orange border. So this one is our coarse end cap for sandwich, which we're gonna use. So we open our Revit, and then we go to Legends here in the project browser, and we have something called Impact End Cap Legend. So we can start that view, and this is what we get. So we can zoom in here, and we see the same as we did for the or in the course material. So the first thing we need to do is to create the detail lines. So we'll start with the level of detail 2 here for the database. So we start with the outer geometry as we go to annotate, because we are now going with detail lines, and before we have worked with model lines. So detail line, and then we can switch line style. This is not necessary, but now in this first time we make the end cap, it is good to have different colors of the different lines to divide them. So I have my end cap profile style, so I'll start that and basically just draw the lines on top of the other lines. And what you can do here is also uncheck this chain, because it can mess a little bit, because we have some reference to draw on. So something like that. And then the next part is yeah, we should also do this insertion point, because it's a little bit tricky to catch it, because you could easily pick this one, but we want a small gap here as well, so that's why it's offsetted here. So we will make some lines here. But then it's time for the lay boundaries, so we switch the style to lay boundary and make those lines as well. And then, oh, I terminated the command, and then in the end, we'll also do RC boundary, so reinforcement boundary. So this line and this line. So now we should have or these here. So divided, it looks like this, and then together it looks like that. So then we can go down one step to this level of detail 1 that should be visible on the shop drawing. So we can switch back to, or we can start the detail line again and switch back to the end cap profile. And here we are only gonna select once, so we don't need to switch lines and so on. But we can make a border around, border around the whole end cap like this, as well as a line here and a line here. So that's the first, and then we want to use these fillings as well, like the colors and so on, or patterns. So we have next to the detail line, we have regions, and if we click down, we have fill region. So then we can, first of all, in the properties, switch so that we have concrete, and then we can use this, yeah, we can also draw the lines. So just draw on top here. So first, it doesn't matter if you do inner or outer panel first. But I did outer panel, and then before okaying with the green check mark, I'll also do the inner panel so that we have both in the same detail here. And then when I'm happy, I'll click finish and we'll get these two filled regions. And now it's tricky to see what happened, but it's because we have the reference behind, but we're gonna delete that later. And then we do the same, but for the insulation. So filled region, switch to insulation, and then draw the lines like this. Then we'll add some dimensions, or these two. So first of all, the aligned dimension, and do it from this dot to this side here. It will snap on this, and since it's quite small distance, we can just use this dot to change it to here. So that's great. Then we'll do this angle. So we'll just switch dimension mode to angular, and just take this and this, and then we'll have the dimension. So now everything should be there, and if you just go around a little bit, you'll find this detail group, this dashed line. So this is the background of this that we, or the reference. We can delete it. And before we continue, we'll also add dimensions for the layers. So we'll start align the dimension again, and then start from top and go to the layers and place it like this. So this is the information we'll get on the shop drawing, which is more than enough for this type of end cap. So now it's time to create the end cap in the database, and you go to impact, and you see that a lot of commands are grayed out, and that's because we are in a legend view. But for instance, the walls here have some that are active. One of them is wall end caps. So we'll come here and make sure that we are on project, but switch to sandwich. And here we'll create a new end cap called 115. So new WD 34-115, and then we can call it 45 degree, so that we know what the end cap is, just seeing it in the list. So we'll start with selecting level of detail 2, which is also the default here. So first we will click on pick geometry, and then here in the lower left corner, like here, it says select end cap outer geometry. So we'll just go around here, something like that, and then finish up here, and then pick origin, so bottom left point, so this one. So now we get this, and now we need to divide it into layers. So we'll use the pick layer boundary, select layer number 1, which is between inner and the insulation, finish, and layer 2, and finish. So we have something like this. And then we'll pick the reinforcement boundary, so these red lines, like these two, and then finish. So then we also have the red lines here. So now we have everything we need for level of detail 2. So then we can switch to level 1 and pick geometry. And now we just pick everything like this and finish. So this is what will show on the shop drawing. Then you can also connect custom materials and reinforcement to the end cap, but that's a little bit more advanced, and we won't cover that in this training. So now we're happy, so we click OK, and it's time to take a look at the end cap for the balcony. So these are the steps we just did. We'll just scroll through them. And the balcony we already created, and we used end caps that we got this slope, as we can see here. But to make this slope, we need to have some specific end cap for the balcony. So we'll have this right end cap here as an example. So first of all, we will select this end cap, or not this end cap, but this balcony as an example, and select the balcony and edit and remove all the end caps, because we're gonna start from scratch. So we'll go to here, also close or save with OK. Go to the 3D and click this and balcony, edit slab here, and basically just now I'm in a side where it says none, so I'll just say copy to all. So all end caps are removed, and then we'll update the lifts. We'll update them again when we apply the new end cap, but we'll update now as well. So we'll also need some preparation for this, and we'll use the same concept of creating the end cap with level of detail 1 and 2, the orientations and so on. But for the slab end caps, there are one more thing to think of, and that's probably easier to check here. So since a normal end cap is just continuous, it's horizontal, then you just create it like the end here, or this end where something happens, and then like in this point where nothing will happen again, you just stop, and the end cap will continue until it meets another end cap. But for the balconies, when we have the slope here, then we'll need to create end caps that have the same size as the slope. So this means that a end cap for a balcony that is 2 meters wide will have, you create one set of end cap, and then for a balcony that is 2.2 meters wide, you need to have another set. So they can be reused for the same width of the balcony, for the different lengths, as soon as the width is the same. But if the width is just differing 1 millimeter, then you need to create another setup. So with that said, we'll continue with the preparation, and the easiest way is to just take or look at this balcony from the section. So we'll take the section that we used for creating the recesses and also the stairs, and just move it so that it's on this balcony. So we'll go to level 2 and move this section, and then we can right click, go to view, or double click here. So go to section 1, and this is the view that we get. The first or the easiest way is also to first switch to parts, so that we see all the details, and also switch to wireframe, because now here it's a little bit tricky to see. So wireframe. So now we can see here that, yeah, this is where the slab is stopping. Actually, it might be better to show original here, because then, yeah, it's much easier, because then we don't have the end cap for the wall. So why do we do this? We need the length or the width of the balcony, and also the height, of course. So we can use this aligned dimension, or go here to annotate an aligned dimension that we just used, and just measure. So make sure that you click the correct side here. So we should have a balcony that is 2.04 meters and 185 millimeters thick. So this is the information we need. So we can now transfer again to the impact Endcap legends and scroll out a little bit. And here we see some balcony endcaps. So we're going to use this view or this grid here to create our endcaps. So we will just select the titles or we can select everything, but then I'll just have shift pressed on the keyboard so that the small minus will appear next to my mouse, and then I'll just select the content here as well, because then I'll just copy the thing around. And then we have the copy command up here, so I'll just take this corner and do like that. And then we'll add another letter. So we'll just double click so that we get to edit and make this one FA and this one FB or BA, sorry. So BA and FA. So back and front like this. And then it's time to start. But before we can actually start now. So outside here, we'll start drawing the rectangle. So with the detail line and Endcap profile. So it was 2040 millimeters wide and 185 thick. So make a rectangle like this. And then we'll need to add some details. But first, before we make the geometry, we need to think of what is the thickness of this end cap or the slab. What thickness of the slab will define the end cap. So yeah, I'll show you the documentation. So when we are joining two end caps, the open, let's say, part. So this part here and this part here needs to be the same. So we cannot use this as the slab height or not this either. So it needs to be this part that is the defining. So this should be 185. So since the back should have this extrusion, we need to make it a little bit bigger. So we'll create the geometry. Let's see, like that. Geometry with these dimension lines. So yeah, if we take this first, it's going to be 148 up. Then 20 millimeters in, we'll have a 20 millimeter, let's say, recess or triangle that is 10 millimeters high. So we can do that first. So start detail lines again and just draw on top of it. So it was 148 millimeters. So that was the first. And then we can just make a help line. We can do it in different ways, but I just make a line that is 20 millimeters. And then I can snap the end point and make 20 again. And then I'll snap the midpoint to the triangle and 10 millimeters. And then I can make this recess like this here. And I can now select this line and just make it like this. Delete my help lines, and I have the shape. So on the other side here, it's quite a lot more dimensions. So first of all, it should be 200 millimeter thick in the end, and that should go for 150 millimeters. So we'll start the detail line again and go 200 and then 150 After 150 millimeters, we'll have 15 by 15, so it's a 45-degree slope. And then we'll start with 10 millimeter, and I will tell you more about that soon. So 15 to 15, and then like do this. So again, there are more than one way to do this, but yeah, just find the one that works good for you. Then detail line, start that command again if you closed it. And now we are going to prepare the slope here. So for the end cap to work, we need to have 10 millimeters of straight or horizontal plane here. So that's the last part of this end cap, and then the same for the other end cap on that is gonna slope. So we'll end up with two 10 millimeter pieces like this, and then we can draw a line. So I can start the detail again, and you see here that's the first one, that's the end point, and then that's the start of the slope, and then I can just drag it to my new line there, and now we have something that looks like the end cap. So first I can delete these lines. So this looks perfect, and here it looks very good as well, with the difference that that we don't have the straight part, or the yeah, we have the straight part here, but it's not cut as it is here. But that will do now. So we'll just copy this one. So select and copy, because we're going to use this profile to create the end caps. So I'll create a help line here in the middle of these 10 millimeter wall lines. So here, like that, and I'll now trim it. So go to modify and trim, and take this one and this one. So now it's divided, and I can delete the back part and this one. So then we see that we have a 10 millimeter horizontal here. This one is horizontal the whole way. It's 185. So this front end cap is fixed. And we'll do the same here again. So annotate and draw line. This vertical line here we could have drawn before copying, but it's not that hard to draw it. Then this line we can delete. So then we have the gap there, and then modify, trim, like this. And delete that line, delete this line, and also delete these. So we are pretty much done. So we have the geometry, but the thing we need to do first is to mirror this one, because it should be lower left corner, and lower left corner is here. So that's the open part, so we need to have it mirrored. So we can select it and go to either draw a mirror axis or pick the axis. And then make sure that we use or uncheck copy, and then it will be mirrored like this. And we can place them in the views. So we'll start with this one maybe, and just select, and then you get the move. Otherwise, you just use this move. Place it, and yeah, it could be nice to place it aligning with other end caps. Do the same here and align that. Something like this. So now we have all the thing we need for the geometry for the database, but then we also need the end cap for the or the detail for the shop drawing. And of course, this part needs to be the exact length. That's why we took the section and measured. But the details for the shop drawing doesn't need to be the same length. So we in this project I've used 400 millimeters long details of the geometry. So we can just continue doing that. Yeah, we'll prepare the Endcaps in the same way as we did before. In this case, we don't have anything to draw like a reference, but I'll just take a copy like this here. So select both. I'll select by both with holding down control and then copy. And then on this first one here, it's 175, so this one needs to be extended. So I can just first select the line and then select this dimension and say 400. And then this one that is also yeah, it's not going to be straight, but I can then, yeah, either I can do it with the exact slope, or we can actually do that. So the easiest way is then just to take this part and copy it. Just copy and place it like this. Take it again and mirror, and mirror around here maybe, so that the slope is the other way. And then move with this move command and put it there. Or I could just have made a line that is sloping more or less the same as the real one, but now we get the exact slope, so that's great. Then we need to trim it, so we go to annotate, detail line, and make a line like this, and modify, trim, and do like that, and delete this, or no, not delete this, keep that one. And then we're gonna do the same here, but it's difficult to just change the length here, so we'll just make a help line, and then why not try another tool? So we can use this offset maybe, and put the offset up here, so 400. And yeah, when we put this or select this line, so what side of the line we are selecting, we get to preview these dashed lines. So make sure that we have it on the right side, and then place it like this, and then extend it like that. Go and trim, and now we have two end caps that are, or details for the shop drawing that are 400 millimeters. So this will make a consistent view of the end caps on shop drawing. So here we'll make the end cap or these dimensions like thickness and width. And here it might be a good idea to have the angle and also this distance maybe. So we'll start here, go annotate and aligned, and do 200, and then from here to this point do 150. And then here we'll do this one to this one, and here we'll make the angle. But if we switch to angular and take this one, and then it's very tricky to find something to work with. So the easiest way, which is not gonna be visible, is to add a small detail line here. So zoom in and just make it like 1 millimeter or something, because when we zoom out, nothing will be seen. And then we can use that for the angular dimension. So something like that. And then place it where it makes sense. So something like this maybe. So now the dimensions are fixed, and we'll also have a nice filling. So go filled region, and now instead of drawing the lines, we can also use the pick. So pick the lines that we have. So like this here. And switch to concrete. and hit OK. Then it will be there, and do the same here. So now we have the two end caps, and it's time to go to the end caps definition, and that's on the slab and slab end caps. So we have the two end caps here, and we'll create new, and we'll start with the one for the front. So it's going to be called the E19 20 40. So that's the width, and then front FA. And then it's gonna, we have 185 millimeters with 40 millimeters, and then it's a front. So it's exactly the same as we have used, but it's just so that we can create our own. And we start with level 2, pick geometry. So this one, and then finish, and then the origin. And since this edge is now, we won't have any gap or we won't have any slope, so we can just put this point. And then we can use the same lines for reinforcement boundary. Like that. And then we switch to level 1 and pick geometry and select this. And then we hit OK and do the same for the back end cap. So new E19 2040 and then BA. So back, start with level 2, this one, same with insertion point. Yeah, here we might need to pick one by one so that realize that it's like this. And then reinforcement, we can probably do like that. Great. And then we switch to level 1 and pick geometry, this one. So it's very easy to create the end caps. So you can save to the database by clicking OK. And now we're gonna use the end caps. So we're gonna apply it on the balcony that we used as an example to create this. So we go to the 3D, and this is the balcony, and I'll select it, go to impact, and then edit slab again, and just put the right end caps. So on this first one, we can just say previous. So this one is selected. This is going to be a back end cap. So we take the one that we created, the BA. Then next a few times, select BA, and then BA, and then FA. And then we hit OK. And we update the lifters. And we can see that the balcony is, yeah, exactly the same as before, but now we have created the end caps for it. So now it needs to be resaved. So we do that at last. Save slab and save. So we'll scroll down so that we are here. So that was the go through of the end caps. So we did one for the solid walls or sandwich walls, and that procedure is similar to all elements. Then we did the special one for balconies. So with this information, we should be able to create any type of end cap. So the next part is that we're gonna create a joint, and then we're gonna actually use the end cap we created for the sandwich walls, the 45-degree one. So early in the training, we used the joints like this, for example, for the corner. And now it's time for us to create a joint definition so that we know how to create our own setups, basically. So we'll start with that, and we'll close this one as well from saving the slabs. And in the wall commands, we have in the second from last, we have the joints. And we're going to make sure that we are on project, and we're going to create a new one, and this one is going to be called AD6006, and it's a 45-degree. So this is the first, let's say the first, part of the configuration, and that's the geometry. So this is like a plan view of the joint. So we can have 4 walls joining at the same time. So that's the first here. And then we have to decide what element types and what end caps to use in the corner or in the joint. If we mirror, and what positions to place, or if something should be rotated. This continuous wall that is used for a situation like this, where we have a wall that is continuous, as we call it, and then we have a like an inner wall attaching to it. Then this joint it can be called, or it can be used with the discontinuous. But we are going to create the the normal one, so we won't change anything there. We will work with the walls 1 and 2, so it should be sandwich walls, both of them, and then both should be this 145 or 45 degrees, 115 end cap, like this. So this is the first step, and if we take it one by one, so this first end cap for wall 1 needs to be mirrored, so like this, and we also need to offset this one so that they are closer to each other. So if we check the numbers here, we're going to offset it by 330 millimeters. So Y 330, and then this one is the same, correct rotation or mirroring, so we'll just use the offset, and this is in X direction and negative, so negative 330, and we end up with something like that. So that's perfect. Now we're done with the first part, and then we switch to the cost and material tab, and here we are going to set up how these 2 walls will be connected, and we will create lines here with the end caps, what wall it's connected to, or not end caps with, but with cast materials, what wall it's connected to, what's the cast material name, what's the family and what type is it, what view, and the view is like a number, so we see view 1, view 2, view 3, so this is like this, so it's like view 1 is top, view 2 is front, and view 3 is right, and so on. So 6 different views. Then we have X and Y, so position, rotation, and also countersinking, if you want to have some cast material countersinked. What phase it is, so either left, right, or front and back, some treatment text, or some offset. So we are going to create a row here, and we're going to start with wall number 1, and we are going to select the 0332 and view 2. So sorry, this is not correct. It was 32, but we're going to use view 3. So we go back here, 0332. So now we're loading it and view 3, and then we can actually create the second one at the same time, like this. View 3, so something like that. So wall number 1, it's this one. Should be rotated 270 degrees and have a negative Y direction placement. So negative 100 and 270. And this one should have a 100 positive in X direction and rotating 180 degrees. Something like that. And then we'll also need to put the faces, and this is front or back. So it will be like this. We don't want any countersinking or no treatment or offset, so we'll just keep them as they are. Then we have two options for because now we have placed it from the top, and now we have two options for distributing it vertically. So the setup 1 here is that we have a distance or offset from top and bottom, and then we have entering a number of cast material to place, and then we are having them divided evenly. Or we do the same with the offset, but then we put a center distance that will be used. We are going to use setup 1, so like this, with the distance from bottom should be 600 millimeters, from top 400, and then we're going to use 2 sets of cast material. And the last one is linear cast materials, and it's another type of cast material, and a good example of when this is used is in this situation here, when we are making this recess, then a linear cast material is great. So we click OK, and it's created. So now we can take a look or we can try it. We can see if it works. So we can go to level 2, and we'll create or update the joint reference. So the same way as we did before, insert, link CAD, and if we don't have this common drawing, we go to Project Manager, right click on Drawings, open folder, copy the file path, paste it here, enter, and we'll go to Common Drawings. So we will use the level 2 joints revision, import units millimeters, and OK, or open. And then we see here that it's going to be, we have 2 on top of each other, of course. So view visibility graphics, or VV, imported categories, and turn off the one for joints that have no revision, so the original. So now we see that this is the one we're gonna use, and we can also see that we renamed it or named it wrong. It should not be 006 but 806, but that doesn't really matter. The important thing is that we get the result. So we'll just select these 2 walls and connect them. So walls here, connect walls, select this one and then this one, and then finish. Then we'll make sure that our joint is selected and it's symmetric, so we don't need to use the different options, and then we hit apply. This one we just configured, so it works. So we'll say OK. And it will insert the joints. And the end cap would look strange, and it's because we have it in show original. So if we switch to show parts, it will look great. So we do the same change here. So select the two walls, finish, make sure that the end cap is correct, and hit OK. And then we can escape. And if we go to the 3D, now I accidentally accessed the bottom walls because yeah, but we can see the bottom walls then that they are changed. So the change should be on the top, but or the second floor, but that's fine. It was due to that if we check here the view range, that we could have changed this one to access the top. But it's fine, it's no problem. Here on the 3D, I will again go VV and turn off the reference. So that's great. Then we can take these 4 walls and change or save the elements. So save walls. So now they are saved, and we are done with the joints. So we have done all these steps here. So the next thing we're gonna take a look at is the MEP-Keys. So the MEP-Keys is a configuration of electrical components like the sockets and the pipes and recesses. So instead of creating or placing them one by one, we have a tool that's called MEP-Key that will create everything at the same time. So we'll create one and apply it to one of the elements to see how it works. So the MEP-Keys can be found here under components. So this MEP-Key command. So we'll create a new one on project level, and it should be called E01. And we can have a description of light switch inside socket outside. And this is the tool that we are using for configuration. So on the top here, we have some general things. So first it's the dimension text. So it's like what we get on the drawing. So and then we have the material takeoff. So how it should be saved. So either if it's going to be saved by pieces or by key. And this is more or less how you work in the production. So do you have a workshop department that will build this MEP key together with all the components before we come to the mold? Then maybe we want to save it by key. Or if we are doing everything at the mold, then we might want the pieces so that we can pick all the custom materials one by one. So, but that's totally up to you as a user. Then the symbol here is just a symbol that we have on the floor plan. So that's the first part. Then we have the items, and it's here we are placing the components like the light switch, the sockets, and so on. So basically the casting materials. Then we have one part where we configure the recess. So maybe we have a recess in the bottom or of the element or something to be able to connect the cables between different elements. Then we have duct connections, so the pipes that we will tie everything together with. And we also have an option to, instead of having a pipe, have like just a recess connection, so that you connect or you draw the ducts afterwards, after we have casted basically. So we're gonna start, and we're gonna save by key, and the text should be the same as the Endcap or the MEP definition, so E01. And we're gonna add two components. So the first, or both should be this 0801. One should be from floor, and this is yeah, we need to stop here because I was a little bit too quick. I also want to tell a little bit about the preview. So the preview here is showing the wall basically, and the red strong lines are bottom and top of the wall, and the dashed lines are finished floor and finished ceiling. So normally when you apply or create these light switches and so on, you want it on a specific height from finished ceiling or finished floor. But if you would reference from the bottom of the element, it would probably differ, because in one part of the building the the bottom part of the element is lower and than in another, and then you won't get the same height. So this is just a tool to help you get the correct height of everything. So the first component will use the floor as the floor as the reference. So click floor here, and we have the dist from edge. So the distance from the floor should be 1100 millimeters. We have something called offset distance. So it's like if you want to switch it into the sides, but this one will keep like it is. Won't rotate or won't do any text or anything. It should not be dimensioned. Also, the side is going to be normal, and by normal it means that it's the side where I pick the insertion point when I apply this. So if I apply it from the inside of the element, it should be on the inside. That's the normal side. If I apply it from the outside, it will be the outside. That is the normal face. Then for the second one, we'll keep the ceiling as the reference, but then have a 200 millimeter distance from the ceiling. Same with the offsets and so on, but the side should be opposite so that we go through the wall basically. Then it's time for the recess. So we'll have a recess in the bottom so that we can connect the pipes and so on later on. So add a row, and this should be 100 times 150 times 80 millimeters. And the edge that it should be connected to is the bottom of the element, so here. But it should not be just directly beneath it, but it should be having an offset. And I want the offset to be placing the recess on the left side, so then we have a negative value of 500 millimeters. It should also be placed on the normal side, so the same as the switch for the lights. Then the duct connection, we have 2 rows. So first, both is gonna be 0, 5, 15. We should have 1 pipe on each, or on ducts. And since we have 1, we won't have any spacing. Then we will connect the first one from the recess, so recess ID, and to the first custom material. So this is item ID1. So item ID1, so this, and no offsets or anything. Then the second one should become from the item ID1, go to item ID2, so like this. But we don't want this like diagonal path for the pipe. So for this first one, I'll just select it and right click, and we have something called adjust displacement. So we have the possibility to bend the pipe so that it's a little bit better, for our element basically. So we have 4 options: either vertical to vertical, and that means that it will connect vertical to both the recess and the custom material. Then we have vertical to horizontal, like this, horizontal to vertical if it's the other way around, or horizontal to horizontal. So these are the 3 options. We will use the vertical to horizontal, so this one. Then we have A, B, C, and D. So B is not used in this case, but the A, C, and D is used. So A is the reference. So in this case, it's going to be our item ID1. So we switch to item ID1 here. And C is the distance of the bend, basically. So we'll have 300 millimeters. And then D is the radius. So we put 200 and hit OK. So then this is the result. And you see no radiuses here, but they will come in the project. So now we are skipping the recess connection because that's not usually used. So we hit OK and OK again. And now it's time to use this MEP key. So we're gonna have some help of the view or section that we created for when we edited the window to a door. So from level 2, we're just gonna move the section as in this image. So from level 2, and we're gonna move it here. So we select this section and move it here. Then we go to the section, either in the section here, select and right click, or as I have the section open. So we're going to place the map key here. So this is the insertion point. So we'll start the command to draw map key. Select the one we created, and then it says select wall, and then insertion point. So we'll put some line here or point here, and the map key will insert like this. So then we can escape, and it will be inserted and configured in the wall. And we can go to the 3D. So we can go here, select this wall, and then select the section box or selection box. So we can see that the outer part will come here, like the opposite part. And then in the inside we have the recess and the pipe up to the socket. And it goes through the wall here, like this. So now we'll just save this element, and we're done with this task. Save walls and save. So the next part is to look at rebar template for columns. So the rebar template for columns is to add the standard rebars reinforcement for this element. So we used it already, but now we are going to create it ourselves. So the first thing to do is create a good or some good views to work on. So we'll start with opening level 1. And this one in the 3D, we can click on selection box now, or section box, so that we reset. Go to level 1, and we will find the column in the grid A1, or A2. So A2. So this is the column that we will work with. First of all, we'll go and start the reinforcement. So we go to structural or to visibility graphics. So either view visibility graphics or VV. Then we can click S and start structural rebars. So that's the first thing. Then, so that we see everything more, because now we cannot see the rebars, we use the visual style wireframe, and this is what we end up with. Now it's a little bit, what to say, it's a little bit messy. So we would like to only see the column. So we will select the column and use the temporary hide to isolate it. So select this and use this glasses and isolate the elements. So this is what we get. It's a little bit more easy to work with. Then we'll open the impact rebars and opening And we'll open the impact rebars and do the same. So we'll find the element or the column. So we'll select it like this and use the isolate like that. And we can see here that we didn't get the rebars for the corbel, so we'll select both the rebars for the corbel um, and the column. So like this. So it's a little bit tricky. So tab until you select both, and then have control, and then control select the column, and then isolate. So this is what we are getting. So the first thing to do is to see these views at the same time. So when we started this project or this training, when we drew the wall, we had the 3D view on the right side. So we'll do something similar, but instead of dragging and dropping the views, we'll use a short command. So we'll close all the views except level 1 and 3D or impact rebars. And then we'll use the short or the keyboard keys WT for dividing the view. So we'll end up with the 3D on one side and the 2D on one side. Then we also see that we have reinforcement in the column. So we'll delete those. So the green and blue ones, we'll keep the ones for the column or corbel because we haven't used or we shouldn't create them again. So we can just zoom in here and tab until we get the different ones here. Like that, and this one, and delete. So this is what we are gonna work with. So now it's time to start, and we're gonna start in the 2D view by tab selecting so that we get only the column like this. And when we do that, in the modify, we would be able to select the rebar. So then we get a list of rebars and we'll find the N shape. And yeah, when we first of all select it, we'll need to go here to the properties and select that it's going to be a diameter 10 and it should be N shape because this all controls the diameter but also the 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 color of it. So now it's diameter 10, K500B is the quality, and N shape. But when I try to put it here, it says like this small stop sign, and it's not placing it. And this is because I need to change my placing plane. So we'll switch it to the far cover one, this one. And now I can place it. So I'll place it like this and click once, and now it's in the element. And we see it also in the 3D. So we need to start modify the placement of it, and we'll make a very simple case now with only one set of end stirrups. So we'll select the stirrup, and up here we have edit constraints. So first of all, we have this where it says 0, 0. So now it's connected to the cover in the bottom. We're gonna move it 200 millimeters into the element, so negative 200. And then these sides here that are not in the cover, we're just gonna move them as well. So click here, and then we'll just switch the face. So now the face is there, and we'll switch it to here and set 0 as the dimension here. And do the same here and put, now the face is correct, but we then put 0. And before we do that, we will do this button as well. So if we didn't do it before, just click it so that it's dashed, because then it will be in the cover. This one I made it wrong, so that's in the face of the column. So click there again, click this, and put 0, because then we're placing it inside. So if I would have done it correctly from the beginning, I wouldn't have done or needed to do it more time than one. Anyways, now the size is correct. So I'll click finish up here, and it's time to spread it out through the element. So up here where it says rebar set, we'll switch to maximum spacing and put the spacing to 200 millimeters. And we end up with something like this. So we want this to be going to the top of the element. So I'll select my rebars, edit constraints again, take this point in the top. Now I'll toggle this button here so that it's in the cover, select the dimension and put 0. Uh, and then, yeah, first we'll need to select the plane. So this is a little bit different, so or different in different situations. So now we can put 0, and it will fill out the whole column, and then finish on top. So now we have the stirrups, and then in the plan we'll do the same again. So tab select only the column, start the rebar command, but now we will do the straight ones, so the A shape. So we'll click the A here and switch to diameter 12 and A. Then these ones should be vertical, so we'll switch to parallel to cover. So we place it like this, and one in each corner. And we will move them correctly, so we'll just place them quickly here. And then one by one, we will select them. So we'll start here. Tab select, so you get only this one. Edit constraints. Click on this so that we go to the cover. Then this orange one is highlighted, so it's this direction now. Select the cover and put negative 15 millimeters. And then select this vertical, put the cover. Now this one is highlighted, negative 15. And then finish. So now it's placed correctly, and do the same on the other ones. So something like that. So now the column is prepared, and now we can continue to create the rebar template. And it's very simple. So here in the reinforcement, where we have apply rebar template, we'll select the definition. switch to column on project. Here we have one called RC, so we'll just make a new one called column, and N stirrups and A bars, something like that. Then select the column here. So click once so that the 3D view activates, and then select the column. And then we have some information that the column cannot be mirrored, but we say OK. And now we have fetched all the ones. Then we also see that we have some C bars. These ones can be deleted because it's the ones for the lifters here. So we'll just delete them. And yeah, then we say OK. And now we have a column template that can be used for other columns. But now we'll just save the column here, save columns. Close that one and then reset the hide, isolate hide on both views. And then we are back like this. So that was everything with the template for rebars. So the next thing to do is take a look at the cast material. So the cast materials is something that is used all over Revit, as we have seen. So both automatic ones, but also placing them manually. And a cast material is consists of two things, and that's the family and the database information. So like very similar to the definitions in general for example, a wall or a column. So there are some requirements. The family needs to be a generic model, and it needs to be face-based. On top of that, we need to have some impact parameters to make the family work with impact, so that we recognize that it is a cast material and what cast material it is, and so on. So we are not gonna go through how to make the family in this course because that's not really the impact part, but more Revit, and there are plenty of information on how to create these families online and so on. But instead, we are going to use a family that is already created and build it up like from that point until we can get used of until we can use the family in Revit. So first we'll go into Project Manager, and in here we are going to find the families that we're going to use, and they are placed on the project level in project folder. So right clicking on open project folder, and we are coming here. Then here is where we will get all the drawings, but the cost materials are part of the standard, so they are not in this area here. So we'll click on the product name up here, and instead of going into the design, go into components. Then we have costing materials, and then you select the folder depending on what Revit version you are using. So I'm in Revit 2023, so I go in there, and then we open the lifter by double clicking. So this is the cost material that we will make sure that we can use in Impact. So it's a generic model, um, that we will yeah, that we will make work with impact basically. So first of all, what we need to do is to add the parameters that is required for a custom material. And these can be added manually, but instead of doing that, because yeah, first of all, it could be difficult to know all the names of the parameters, and also um, you need to use special parameters. And if you create your own, then the connection won't be there in the project. So to prevent all these mistakes, we'll just use a functionality in Impact. So under draw cost materials, most is grayed out, but we have managed family parameters functionality. And this is a tool to add the required parameters depending on what type of family it is, or what the family should be used for, basically. So we have all the loadable families here. So custom materials, beams, hollow core, lattice girder, and so on. This is a normal custom material, so we'll do this, except we won't add the countersinking. It's no harm to add it, but we are not going to use it because you're not going to countersink a lifter. So then instead of overcrowd the family with unnecessary parameters, we can just uncheck it and click OK, and now the parameters are added. And where to find these? We can go up to Create, and then we have this Family Types icon. And this is what we end up with. So these parameters, annotation, description, mark, reference, treatment, schedule, and unique mark controller. So of course, most of them will always be used, but if you just want to add a bare minimum of the parameters, the only ones that are required are the unique mark controller, the schedule, and the sim mark. The unique mark controller is a parameter used so that we can control the element mark. So this one won't ever be used by the user. It just needs to exist in the family. The impact schedule will make sure that only the custom materials will be added to the schedule of custom material. So that's required. And the sim mark is used when we are saving um, the the family to the custom material definition. So these three are the ones that are required, but then again, most cases you want also the other ones, like description and annotation, or sorry, description and reference. Those are often used for yeah, describing what custom material it is, and reference could be the manufacturer, or like some yeah, some stock number that you, the order number, let's say. Annotation could be like yeah, it could be used to show what side, for instance, the lifter is placed in. So for a wall that, like this rotation wall, we can have annotation top on the top lifters, and then side or left, let's say, on the side lifters. And the treatment is something that is unique for the cost materials. It could be if it should be, yeah, have a specific treatment in some way. Um, so these are the parameters, and what we are gonna do is fill in some values for it. So we'll go and check here. Um, so we have two types. So in one family, or one family is like a, let's say, the geometry of the custom material in um, how to explain it. It's the geometry that is parameter, or just parameters, so there are no values. And then each type is basically each size. So this lifter, we made it easy, so it's only 2 sizes, but like in normal case, there would be like 5, 10 of these with different heights and sizes and so on. And the different sizes can handle different weights, of course. So we're gonna fix or add the values for each of these, and we're gonna start with the one called TPA FS 1.4-11. So yeah, we'll start with that one. Go to Revit, and the cost of material marks is often a 4-digit number, where the first, yeah, of course, this is totally up to you how you want to name it, but usually is that the first number is showing what level you are creating this for. So now it's a little bit wrong because we are gonna create it on project level, but yeah, in the long run we're gonna place it on or transfer it to common. So that's why we name it in this way. But the first digit shows what level, and we are gonna start with 0, which is common. Then 1 is local, and then 2 is the project. So the 0 here is showing that we are going to have it on the common level, and then the second digit is what group. So we have I can show you here when we come to the cost material definition. We have different groups to organize the lifters or the cost materials, and the 01 is the lifter, 02 is fixtures, and so on. So the second digit is often the group. So in this case, it's a lifter, so we put a 1, and then it's a number. So you'll probably have several lifters, so you need to spread it out. So this will start with 91. And let's say it's a halfen. And the description is just what kind of lifter it is, TPAFS 1.4-11. And we are gonna place this in the sim folder or schedule, so we'll just add that. So now I also see that I made it on the wrong type, so that's my bad. TPA, I'll just do it quickly here, FS 1.4-11, 0191, halfen, and sim, like this. So now we're gonna do the second one, the one that is ending with 18. So we switch here, and yeah, we'll switch the last things here. The first TPAFS is the same, but then it's 5.0-18, and we cannot have the same sim mark, so we put 2 there, and then we are done. Of course, you could add more parameters, your own parameters, and so on, but this is the ones that are required for impact. So we'll hit OK to save these settings, and the next step is to prepare the view that we're gonna use as a thumbnail for this lifter. So both, yeah, you'll both see it here in the list, or not in the list, but yeah, that was a bad example, but if it's loaded correctly, Windows will show the Revit thumbnail here as well. But more importantly, it's going to be used in the interface in Revit or Impact Revit. So we want to create a view that is just there to um, show the lifter in yeah, in the perfect way, because it could be that I'm going in here changing the how this one is looking like to a wireframe or something like that, and then it's hard to see what we are seeing. So instead of doing that, we have we're gonna add a 3D view that is only for the thumbnail, and then that view will only be used for the preview or the thumbnail and not for editing. So if we were going in here to edit, then we'll be in this view that we are in now, but never in the thumbnail. So we go up here to the project browser and select the 3D view and right click and say duplicate view. We'll see if I can also show it here. So duplicate view, and we select um, the duplicate only, this one, like this, and then we right click and say rename and name it thumbnail. It doesn't it doesn't need to be called thumbnail. You can call it preview or something. The only important thing is that you know that this is not a working view, so it's just a preview. So that's great. Then we're gonna fix the view, and yeah, we're not gonna do much. I'm just gonna change back to shaded and maybe double click on the mouse wheel so that we are centered here. And then we are good to go with this cost material. So it's, if you have the family already, it's not a tricky thing to do this at all. The only thing again is to, yeah, it needs to be cost generic model and face based. So face based you can see here. If I go to visibility graphics, VV, and show hidden lines, we can see that uh, it's like a, yeah, a face that this one is drawn on. So this is the requirement. Great. So now we're gonna save, and we are not just gonna click here on save because we need to make some settings. So we go up here in File and Save As Family, and then we come in here to the product folder. So we're not gonna change anything with the names or so, but we're gonna click here on Options. So here is yeah, the default options to that we have, or that Revit gives us. So every time we save a family, uh, or when we save it again, let's say, then a backup will be created, and the default one is to keep 3 backups. That will, yeah, that will often be too much. So usually when I'm done with a family, let's say I create the family from scratch and then create the parameters as we did now, then I'll go in here and change to 1 backup because that's normally enough. You can absolutely have more than 1, but the recommendation is to have 1. Then the second thing, or the last thing to change, is the thumbnail preview. So we see here that the default one is active sheet or view. So this means that whatever view that we have active, you know, lastly, or yeah, when we close the family, let's say. So it could be a left view or front view or whatever. That view will be the thumbnail, and that's not really what we want because we want to always see the cost material. So that's why we created this thumbnail, and we are selecting that. So no matter what view that you have open when you close the family and save it, we'll always see this one as the preview. So that's great. Then we can hit OK and save. And now what happens is that, yeah, this one is saved, so we can close it, close both views, and the family is now ready um, for us to configure in Impact. So before we do that, I'll also go back here and show you. So here is the preview that is loaded now, and the lifter.0001 is the backup. So all these dot and the number is a backup file. So I can just delete that because it will not yeah, make any purpose for me. So we can go to the normal 3D view, and here in the components, we click on the list, and here are all the components for or commands for the components. So we're gonna take a look at the definitions, and they are all with this gear symbol, and we have a lot of different definitions. So we have first of all the cast materials, and that's the general one. Then we have the lifters, so it's for a way for Impact to know that the thing that we are configuring is a lifter. So when we are creating a definition, let's say that we go here to walls, um, and yeah, we can take this one. It's not really a big deal. Go here and click new. So then the list that I get here is only lifters for solid walls. So this is a filter so that I don't get like welding plates or whatever. The same thing is for the bracing. So here we only list the bracings. So that's why we have different categories, but also there will be some different yeah, functionalities, of course. And then lattice girders for form slabs, dynamic cast materials for like yeah, anchor channels or whatever, linear cast materials for the yeah, the example we had with the joint, if the joint is connecting with a continuous wall, and then end stops is for double walls and form slabs. So this is a lifter that we created. So we click on lifts, and let's create it for the sandwich walls. So we switch to sandwich and click new. And then here it's important that we put the same name as at the sim mark. So if I would do like this, 01, sorry, 0193, then nothing will happen. And if I load and select my lifter, it will say that it does not contain the correct mark. So I need to be remember what name I gave it. And then the description, so FS 1.4-11, like this. And then we need to set the group, so lifters, and yeah, if you want them to yeah, to have some different options here to not contain or not do save into the database. Sometimes we have cast materials that maybe an erection cast material that we don't want to be saved as cast material, but it should be just there, and so on. So there are some settings here. Then we have the panel thickenings, and it's now zoomed out, but it's these here that you get automatically for the walls when they are when the lifter are not inserted in the concrete fully. So we'll set that up, and it's these values. So we put 300 by 300 and 70 millimeters in C. And then we can hit OK, and the custom material is there. So we'll do the same for the next one. So 0192 FS or TPA FS 5.0-18, and the same lift and the same size, like this. And now we have the custom materials. So if we would go to draw custom materials project, then we get our lifters. So that's all from the components chapter. So if we go back to this here, we can see that the next thing to do is the shop drawings. So we have now in this chapter went through the Endcaps, the joints, the MEP-Keys, Rebar templates for columns, but it works the same for other element types. It's just an example here. And then now previously we did casting material. So it's time to switch to the shop drawings, and then we are taking a look at the normal drawings like plan drawings, elevation drawings, and so on. We look something a little bit at the schedules and reports, and then we are done with the training material. So yeah, the shop drawings. We're gonna first take a look at creating shop drawings. Then we're gonna look at how to modify our drawings, how to create the PDFs, and then in the end we're gonna look at the shop drawing templates, like the background or the thing that we are using to create our shop drawings. So let's get started. So we're gonna create the shop drawings, and the shop drawings are generated when the modeling part is done. So in this exercise, we'll do shop drawings for sandwich walls on level 1. So we go to the model and start command create shop drawings. We'll select the template from project level, and it's going to be the sandwich wall. And then we select the walls on level 1. So you see here with the small minus symbol when all the walls are selected. So we go through the building like this. So something like that. And then when we're done, we click finish. So creating the shop drawings will take some minutes. So now we have selected quite a few walls, and each wall will take up to some seconds. Let's say 15 to 20. In our case, a little bit more, probably because of that we have 4 sheets. Then here is a mismatch in the naming of the tag family, so it's not a big deal. I'll just click OK. This could be fixed, but it's nothing that we need to care about. It's not going to affect anything on the drawing. It's just that we are going to have another family, basically. So we'll just wait until the shop drawings are generated. So now the drawings are created, and it took a little while, but it's not really a lot of time if we see what we got. So each drawing here, each of the element drawings here took about yeah 25 to 30 seconds. So it's not that or in that time we Impact made a lot of sheets here with a lot of content which we are gonna take a look at. So it's quite all right. Um, we can select one of the drawings, um, and yeah, as a start here, we select all the elements here, but we can also select specific drawings by doing like this here, then specific sheets. So this is how you can do it. We'll take a look at any of them. I'll take some random one, this one, and start all the sheets and say OK. Yes, so now the drawing is generated and we'll just order them like this. And this is what we are getting. So the first one is the main drawing, as we call it, and this is only how we have set it up, and um, not anything else. Uh, so the main drawing will contain one view of the inner panel and one of the outer panel with all the measurements. One section for vertical and one for horizontal, and some tables so for the openings, for the casting materials, and for MEP-Keys. Now we didn't have the MEP-Key in this one, so it won't be visible. Here in the top we'll also have the data from the element, like volumes and the masses and so on, if it's ready for production and so on. And then we can also get the values um, for the specifications is the word. So this is the first drawing. Then we have something called the 3D drawing that we prepared, and here we also see the details for the end caps. And we have a 3D view which we can use to create 3D details that is going to be looked at in some steps as well, how to do that. Then we also have one view each for the reinforcement in inner and outer panel. And the reason why we have one view each is that we are showing a lot here. So now we don't have a lot of stirrups, but normally this list is filled with stirrups with all the parameters that is interesting. So this will take some place, as well as if we are using bended mesh, then we have these tables. So it will take some space, as well as we want to use the 3D details here as well. We also get a straight bar table and a mesh panel, and then the same here for the outer panel. So that's the drawing, and you can pause the video and go ahead and create drawings for the other element types we have created. So the column beams, inner walls, stairs, slabs, hollow cores, and take a look at them. The procedure is exactly the same. The only thing that differs is how the drawing is set up. So the sandwich wall is the most advanced one with 4 sheets. Then, for instance, a hollow core is prepared with 1 sheet. So they differ because of complexity and so on. The next thing we're gonna take a look at is the modification of shop drawings, and we're gonna start with adding a section view. So we are going to add an additional view here. So normally you create the drawing when the element is done, and then it might be some small things to modify manually. So yeah, it could be moving some texts, adding some dimensions that didn't yeah, come in automatically, and also add sections. So we'll try that, and we'll make sure that we have the main view open. And if you don't have it, or if you closed the drawing, as I did, you can open it by go to Open Shop Drawing. So then it's the same dialog as we got when the generation of the shop drawings was created. So I'll take a drawing here and open the main and hit OK. So for this drawing, I want to add a section, and you find the tools under drawings, and we have this add section view. So you have a prompt here in the lower left corner as usual. So it says select base view, and that's like the main view. So we click there. Then it asks us to say where the section should be added. So I'll put it here in the opening or in the window, and then where the view should be placed. So let's say here. We can always change it later and make it better. So I'll call this one vertical section 2. In like normal case, you might want to like in the template change this to a 1 or 2 or 1 or A, and then the other number or letter here, so that you can have 1, 2, 3 or A, B, C. But here I have vertical sections, so I'll just deal with it. Also, I want to add dimensions to the section. This is if you don't want it, you can just uncheck it. Then you decide what type of section it should be, vertical or horizontal. We're gonna do the vertical, so that's correct. And then the flip direction is the sections can be different or seen from different sides. We saw that when we used the sections for, like in the model for making recesses with external reference with the pipes, changing the door, the window to a door, and creating the stairs. So we had this flip arrows, and it's the same as this flip direction. So according to how my template is set up, I'll also need to flip this so that I get it in the same direction. Then it's time to select a reference view, and normally it's you will like to have the same reference or the section as the reference. But here, so it's automatically taking that. But here you could also switch if you have some other um, plans, and you can also you say that okay, here I don't want main geometry to be dimensioned, for instance. Then you decide the scale. So we take the default scale, of course, and then what view template to use. And the view template is also automatically taken from this view here that is selected. Then we have the far clip offset, and that's basically how far the section will see, basically. So I'll put mine to 500 millimeters. And then if you want some rotation, that's more for column shop drawings, usually. Then we say OK, and a new view should be generated here, also with adding section arrows. And yeah, it's tricky to put the correct placement at start. So when you have it generated, you can just select it and drag it, and it will snap here on when it's aligning with this view. And then just put the tag as you want it, and we have a view now. And yeah, the same procedure is for horizontal views. It's just that you select horizontal here instead. So next thing we're going to talk about is the updating the drawings, and there are no exercise here, so we'll just focus here on this page. And even if I said that you do create the drawing when the element is finished, there are normally a lot of revisions done after you create your drawing. And when we have a lot of changes in the revision, we need to, of course, update the drawing as well. So the procedure here is done or can be done in two steps or two different ways, depending on the how big or small the revisions are. So if the revisions are big, like a lot of things are changing in the model or in the specific element, um, like we are removing things, we are adding things, we are moving things, and so on, then it might be the best idea to just recreate the drawing, and that's the first option here. So what how the process looks like is that you make the revisions in the model as normal, and then save the element again because we need to have the latest information in the database. Then we go to impact, drawings, and create job drawings again, just as we did with when we generated all the drawings. But then instead of selecting all, we just select the one or two walls maybe that have the revision. And then when we click on finish, that's, we want to create the drawings, we get this dialog that's saying that the element already have a shop drawing. Then you will just click replace, and the drawing will be created as from start, and all the revisions will be there. So this is when the changes are a little bit bigger. Then we need to just recreate the drawing, because otherwise it's a lot of manual work that needs to be done. But then it could be that it's only some smaller things. Let's say that one of the lifters are changed, or um, or like just the size of the lifter, or bracing, or a welding plate. Then it's not a big deal. So what you do is you change it according to the revision in the model, save the element. So let's say that it's a cast material that is changed in size. Save the element, and instead of generating a new drawing with create shop drawing, we have the draw or update drawings. So we can take a look at the functionality. So it's just here, and you select the wall, and this dialog will pop up. So here you can decide what to preserve. So basically, what to not update. So if you have changed a cast material from one size to another, then the only thing you need to do is to update the dimensions. So we uncheck number 4 here, and then like reinforcement annotations, spot elevations, and the 3D details will be as they were. If you would have all of them unchecked, then all the manual things that you've done on the drawing will be gone. So this is a way to update just a few parts. So two ways of updating. If it's a lot of changes, the best way is just recreate the drawing. Otherwise, it's for small changes, it's good to update. And it could be also that if you're unsure, try with this update first and see if you are happy with the result, because you can always go back and recreate the drawing after that if you feel that that's the best solution. So the next thing we're gonna take a look at is the detail views, and we are going to to take a look at one of the drawings. And in the when we added the section, we saw how we can open the drawing from the interface. but now we can also take a look at how to open it from the product browser, because all of the drawings are placed in the product browser as well. So in the bottom here, I'll just minimize a little bit. So in the bottom we have assemblies, and if I expand that, I have all my elements from the model. And yeah, of course this is not a really big model, so it's not that many, but it can soon be a very long list. So it's usually most or a lot easier to open the drawing from this command here. But if you want to open it from here, you can just see that, okay, this is the SW106. Then we expand that one. So the ones that have this plus means that they have a drawing. So this S112, for instance, it doesn't have a drawing yet. Then we can double click on sheet 2, and this is where we're gonna start working. So we'll go here to the view of the shop drawing settings or shop drawing tools, and we have add detail view. So this one will pop up, and we will put a name, so D1, and here we can change the scale, for instance, or offset. And offset is like a distance multiplied with a scale. Then we select the components, so then we go into the main view. So we have this prompt here, select viewports. So this is the main view, and then we zoom in and select the lifter and the stirrup. Say finish and place this one somewhere here. So this is what we are getting from start. Then of course we can make some changes. So we can, for instance, make the scale different. So if we do 5, for instance, it will, or the offset, sorry, 5, it will go in. So we'll just find a number that works for us. Then this view here maybe needs to be rotated so that it looks good here, and so on. We can set a view template, so this 3D maybe, and hit apply, and then it will be smaller, so we'll just keep no template on it. We'll do something like this first. So like that. We can specify how this tag will be placed. So first and second quadrant, it will be shown here, third and fourth as well. What text style to use for the tag, and then we'll just tag the components, so both the cast material and the rebar, and then we can click apply and OK, and we'll probably just go in here and select the tag and just place it according to what we want. So something like this. So you see the detail for the element, and then we can double click outside, so we like this. And in this way we can build up a solution for the details. So we can just do switch here to so that we get the name here as well. So we can make a solution for the details in 3D instead of showing everything in 2D. So complex places, it could be a good idea, or how to reinforce cast materials. This is a very unrealistic and a simple solution, but with the correct rebars around here, it's very easy to see how to build this in the factory. So if we did some changes or want to do some changes, we have the edit command where we select the view and we can go in and do changes. The same is if we are not happy with one, we can delete, selecting the view and then finish. And we'll delete. So we can of course delete here as well, like select and delete, but then we also need to delete the tag. So deleting with this tool will do both. So that's about it with the 3D details, or detail views as it's called. The next thing we can take a look at is the drawing properties. So each element or each drawing carries properties for the element and for the element and drawing, I mean. So we find the properties in this list here, drawing properties, and this is for the sandwich wall 106. We have who designed it, me, and design date. I have fields that I can fill in for checked by, improved, and approved by. Approved date can also be set, but that's only for the statuses as built and building drawing. So that's when the drawing is approved. Categories and statuses are, or statuses is like what state the drawing is in right now, and category is something used in Sweden, so it's very similar to the status. Drawing type, project title, and project description will come from the project manager, the project properties in project manager. And then we have some free text fields. So here you can use the fields as you want to. And we have also this drawing description. And all of these informations will end up here in the drawing panel. Then we also have the specifications like this here. So here we can set or change the values that we see here in the property or specifications view. We can say cancel here, and the drawing properties can also be found from or seen from the project manager. So if we open here and just check the same here, 106, then we can right click and go to properties. Then we see the same. The dialog looks a little bit different, but it's more or less the same. And instead of having different tabs, we reach the specifications from here. So from here, you'll make some modifications on specific elements. The next thing is to check the functionality for update status. So this is also a functionality that we'll just talk about, the no exercise. But we have seen in the model that if we go here and to the update status, that we can, yeah, if we have some modifications on the elements, we can get or we get different colors, like gray is updated, and orange and pink is unmarked and modified. So in the similar way, we can also check the statuses or update status of the drawings. So it's tricky to know which drawings that you have, updated if you made some revisions and so on. But then we have this shop drawing update status. So starting that, Impact will take a look at all the drawings, and we don't have anything to update here, so it is all with black text. But if we check the material, we can see the two options we have, or three options. So the black ones, as we saw, that means that everything is up to date. The purple ones, these ones here, it means that we have been saving, or we have resaved the elements, but we have not updated the shop drawings. So with this functionality and checking or selecting these four elements and clicking update drawings, we'll use the update functionality. We can just go back quickly. So this update on the drawings. The red ones means that the element has been modified but not saved, and the shop drawing has not been updated either. So in this case, we need to close, save the element, and then we can come back here and update. So the difference is basically that the purple ones or both here, both the red and purple are updated, or the elements are updated or modified, but both are modified, the elements. But the purple one, we have saved the elements after, the red ones are not saved. So this is a good place to just start and just check so that we have updated everything. The next part is also something that we'll take a look at just to check and not have a exercise, but it's the drawing status. So we saw in the properties for the drawings, so we can check that again. We saw that we have this status to change in the properties. But what if we have like the first floor, all the sandwich walls are fixed? So instead of doing it for one element at a time, we have the possibility to use this set drawing status. And in a similar way, we'll take all the drawings and we can then set the statuses here and then update. Also, we can select several and then we update down here. So it's just a tool to make changes on several places at the same time. And these two are just explaining the selecting one or selecting a lot of elements. But for the revisions, we'll actually do some exercise. So we'll pretend that we have a revision to do, and it's a little bit of a process to go through everything, but it's of course important. So the first part when we create a revision is to do it or add it in Revit. So that's where we are gonna start. So in the View tab, we have under sheet composition, we have this revision. It looks like a revision cloud with some arrow. So we can click there, and we are getting the revision dialog basically. So here we can get, or here we will basically put all the revisions in the whole project. So usually when we work with the precast elements and shop drawings, we want the numbering to be per sheet, which means that the numbering is not set here, but it's on sheet on one shop drawing. We start with the revision A, and then another shop drawing we start with revision A there as well. Having this numbering per project, then we'll put the numbering either one or numbers or letters here, and then we'll have a drawing where we start with the revision A, and then another drawing where the first revision is C or whatever. So usually we want to change to per sheet and the information there. Then here we are setting up the revisions, and there will be a default one available, so we can just start with that one. We put some date, so 2025-03. Yeah, let's take today, or let's say some days before 25. Then here you put what changed. So this one is changed lifters, for instance, and that's enough. Then we can add another one and put today's date. Uh, and then here we say that we recess move 50 millimeters, something like that. So this is the first step. Then we can hit OK. So now the revisions exists in the model, but the next step is to add them on the drawing. So or apply the revision as we call it. So we go back to our main drawing here, and we are gonna apply the revision, and that is done in the bottom of this properties. So we just go down, and yeah, it's not really in the bottom, but almost. Then we have these revisions on sheet. We can click edit, and then we just select which revision to apply. So this one here, I've changed the lifter, so we hit OK. And what happens is that I get my current revision letter down here. I get my the whole revision information up here. So that's the way you do it, and you activate that for each sheet. And one important thing is that now I'm on this SW100 106, so I'll open the rest of the sheets here as well. Open shop drawing 106, that one, and 3, 4. So here we can see that, okay, this is my drawing. So if I want the revisions to come on the drawing and not the individual sheets, then I need to apply it on all my sheets. So in this case, go down here and apply it for this one and for this one as well. If I wouldn't do that, and let's say that on this, or I have another sheet, another revision, and let's say that it's something with the reinforcement for outer panel. So it's the revision should be here, but yeah, it is for the drawing. So if I add a revision on this one and don't show the first one, but only the second one, then this one will have A as well, the same as here. But A here means changed lifters, and A here means recess moved. And impact will only handle one revision at the time, or one letter at the time. So here impact will say that we only have one revisions, but it's actually two. So the real deal would be to activate both if they are relevant for this drawing. It could be that the recess moved 50 millimeters is for another element, so SW110, for instance. Then, of course, we don't need to apply it here. But basically, the important thing to know is that we need to have a situation where when we add a second revision on the drawing, then we need to have all sheets having the revision at start. Otherwise, we can have like this that I just showed, that main have revision A, changed lifters, then inner panel have revision A, but that's another revision. So that's important. So now when we have the revisions on the drawings, we can, I'll just add both here as well so that we do it correctly. I don't want to show the way that we shouldn't do. So this is great. So to save this to the database, because now they are existing here, but maybe we want to have the same information in Project Manager. So what you do is basically starting the drawing properties and then just say OK. So we don't need to do anything in that dialog. It's just that when we start and close it, or basically not when we start it, but when we close the drawing properties, we will also save such things as the revisions. So if we go back to our project manager and click on update, we'll see that we get the revision in the drawing list. So we can also right click and go to the revisions here in the middle almost. And from here, we also see all revisions. But make sure that you don't add, edit, or delete any revisions here, because that's not working for the Revit. Here we only view it. Those three commands are for CAD users. So that's it about the revisions. So next we'll have a look at creating PDF drawings, and that we also do from within Revit. So I'll close my my drawing here, and I have the print functionality. So this is very easy. First of all, we need to select a plotter. So we have this Revit PDF creator. That's the internal Revit PDF creator. So we'll just have that. Here you can also, if you prefer to have some third-party plotter in Revit, then you need to install it, of course, but then it will be available here. Then you will have the list of all the elements that have a shop drawing, and we can see that we have two things here. We have the element mark, or the drawing number or name, and then we have some IDs down here. So let's say that this would be this wall would exist in two places. Then we'll have two checkboxes here that are grayed out, but with different element IDs, so identifications for the different element instances of the same mark. So we have an example here. So here for the hollow cores and for some of the sandwich walls, I have more than one instance of the same element, and then you get a long list of that. And that's just to know what element IDs that we have here. So that's great. We can just select a few and click on OK. Before we click on OK, we also see that here we have some settings on how to print, if it's going to be color or not, what paper size, but then we'll take the default one from the template, landscape or portrait, or if you want to center plot or have some offset and so on. So we are happy with this. So 101, 100, 101, 104, and 105 will have the drawings. So it will take a few seconds to plot each page or sheet. So that's why we only took a few now. It's the same principle as when we generate a drawing. Each drawing takes X amount of time, and then the more element you select on doing this at the same time, the more time it takes. So this one would probably be done soon. We have the progress bar down here in the lower left corner to help us see that things are happening. So I think it's the last element that will be plotted now. And here it's also that if we would have a hollow core with only one sheet, each drawing would take just a fourth a fourth of the time, so 25% of the time. So it's depending on the amount, or yeah, the amount of sheets in the drawing, basically. That's great. We have four out of four shop drawings exported. So here we get the information if we had some issues, but normally you will get 4 out of 4. And these drawings can now be accessed from the project manager. So if I opt it here, there are several ways of checking these drawings. So right-click, open PDF drawings or in PDF viewer. So PDF viewer is the internal one, or Open PDF will open external PDF viewer. But we'll take the internal here for just an example. So all the sheets will be generated. Then we have the same on the resource manager, as it's called. So if I open this a little bit bigger, this is the application for people working with the impact production. So from there, from the cost planning, they can open the drawings as well, and also our mobile app. Uh, we can also open the drawings to see when we are on site or on the storage yard or in the factory, or yeah, wherever. So that was the creating and modifying shop drawings. So the next thing to take a look at is the shop drawing templates. So basically take a look at behind, or what we had behind our shop drawings here. And this is also, or not also, but this is the first thing that we go through that is yeah, advanced and will not be covered in this course. So if before we start here, if you are interested to yeah, learn more about this, you can click here and you come to the link where we have all the um, different guides on how to set up a shop drawing template. You can also contact us at Strusoft, and we are happy to schedule an individual training with you to learn how to create and customize the shop drawings or shop drawing templates. But anyways, we'll take a look at least so that we know a little bit what the shop drawing templates are. And in as a start, we can say that it's a two or exists of, or consists of two things: a Revit family template, which contains sheets, views, settings, parameters, families, and yeah, basically the thing that we see here in Revit. Then we have an XML file which contains the impact stuff, so functionalities, what to dimension in which view, and all the parameters and so on. So we'll take a look at the shop drawing template for sandwich, which is the one that we just used, and we find it by going here to shop drawing templates, and then we'll go and look at the project template for sandwich wall, and we hit edit, and we are now opening an external file. So it's not the same file as we have in here. So we can switch. So basically, this is more or less the same as a small model. So we see here under assemblies we have the wall and we have all the sheets. So if we switch to the main here, this is the setup for our drawing, and it's very similar to what we see in here in main the generated drawing. So we'll take a look at the settings. So we can go to the impact tab again, and up here we have shop drawing settings. And from here we'll also set up the views. So this is where we're starting. So in the general tab we have some file path of our template, just so we know where it's located. Then we have this drawing category that I told you about when we looked at the shop drawing, this shop drawing drawing properties, it's called. Then we have the status, and that's this is the default status. So every time we generate a drawing, it will be preliminary drawing in my case. We say what drawing type it should come to, and this is controlling the specifications here. We'll come that to in a second. And then what element type. So this is to filter out so that we don't, if we select a solid wall, then Impact will tell that we have the wrong shop drawing template. Then if we have created a new shop drawing template and want to import dimension settings that we'll look here or see here in the second tab, then we can use this button to do that. And then we have the description of what template it is. It's in my case it's just a sandwich wall, but it could be more detailed that you have 3 or 4 sandwich wall templates, but for different situations. I don't know. Then we have these two bind parameters and load annotation families, and that's tools to load the parameters that are used for the shop drawings from the shared parameter file. So that's a little bit technical, but that's the tool. And then load annotation families is similar. So we load the families like tags for these custom material dimensions and so on, for instance. We load that from the standard. Then if we go into the drawing views, we have a setup of each, first of all, sheet. So up here we have a list of the sheets, and we work on one at a time. Then we have some general settings like what title block it is, so like the drawing frame. If we should do this called append assembly name, which is basically like this sheet is called one main, but if we have this append assembly name, we'll have one main SW106, and this is helpful when you have several drawings open at the same time. Then if you have 10 drawings open and you have 10 mains, then you don't know which element it is until you open the view. And then if you want some other custom suffix after the name here. Then we have the list of views. So this is whenever we change here, all the rest is changing. So if we take the inner panel, for instance, this is the settings that control the inner panel. And up here is a little bit more general settings for the view. So first of all, when we create it, we need to have a viewport controlling where this view could expand. So that we do here. We have, if we have a view template, that's also showing here. So inner panel, for instance, we see that the view template here in the properties is the same here. Then we need to tell Impact what type of view it is, and it's a front view. So here is a list of all the different ones, and depending on what type of view it is, we can we have different functionalities basically. Then we have the scale of the view, and also if we have this scale to fit function, and that's a functionality that works with the view alignment that will reset the scale on each drawing depending on how much space the the element is taken in the view. So if you have that on, you maybe want to have this scale display name displaying that scale varies or whatever. Then rotation could be if you have a column template, then instead of, because normally you have a landscape orientation of the drawing. So instead of having a drawing for the column that is vertical like this, we can rotate it so that it lays down like a beam so that we can have room for longer columns. So then you work with that. Flip view is for the sections. So it's if it's gonna flip, or it's basically if it's gonna look right or left here. Then repeatable view. So it's yeah, when we added the section view in the shop drawing a little bit earlier, we only got one vertical and one horizontal section in each drawing. Here we can click this repeatable view, and in that case we'll get one section in each window here. But that's something that you will decide as a user. So yeah, either you create one and then create the the extra ones manually, or you have this repeatable view active. Then the sections here, if you have a lot of views in the sheet or in the drawing, or a lot of sections, then you don't want to, let's say that we have a vertical section for both the main drawing and for the reinforcement drawing. So then you don't want to see the vertical section in the reinforcement drawing and vice versa. Then we can say that we select like this vertical selection view and say, okay, in which views should we hide the vertical selection? And then it's going to be like in a panel rebar view, for instance. Then we have this construction part, and that's if you are working, or yeah, it's a little bit special functionality, so we can probably skip that. We have the mold up and down symbols, so it's to insert a symbol pointing at which side is up or down in the mold. So it's to help the users at factory orientate a little bit better. Then we have this setting for dimension lines. So we have all the dimension lines down here, but this is for the first dimension line in each side. So it's the offset from the element to the first line. So here we have standard 8, but here you can expand it if that's something that you want to have. And then we have the section placement, so where to place this one and what offset to have in yeah, if we have this repeatable view, for instance. Panel visibility, so I have one elevation drawing for inner panel and one for outer panel. So if we take inner panel here, yeah, that my setting is wrong, but it should be inner panel like that. And if you want to tag the reinforcement automatically, you will select what annotation tags you will use. So for multi-rebars and single rebars. And then for each of these views, we have the dimension line settings. So basically a list of the yeah, available things that we can dimension. So here you activate the things that should be dimensioned and make a list like this. So this one, the Endcap labels, they will be closest to the element, and the panel thickening and other Endcap dimensions will be the furthest away. And if we click on one, then you decide what placement it should be. So closest edge means that if we have this one on the bottom side, then or a cost material on the bottom side, then the dimension will be here. Have it on the top side, it will be here. Then if we have this placement alternative, then we'll always put like on either left or right or top and bottom. So that's a little bit more traditional way of dimensioning, I guess. Then you put this extra settings. So the first one, style extends, is if you have this control measure. So normally we measure from left to right. So in here we use this continuous 2.5. So it's until here for this cost material. But then we have the option to set like a value. So often it's 2 meters. So if this distance is less than 2 meters, then it might be good to also add a dimension for that. And that's the style extends. So the extends dimension basically. So then you can decide, some people wants to have it like in another font to just highlight that this is just a control measure, let's say. So then we have some tags for the dimension lines and so on. So for the different settings here, we have different options and set configurations here. So that's it, and the buttons here will allow you to create new views. So from here we can create a view, select what type it is, what view template. If we want to have some automatic dimension line settings, then we place it and it will appear here in this list. If you select that you don't want to have any dimension line settings, then you can use the import tool here to say that, okay, I want to import settings to this view here, to the inner panel, and the settings should come from the outer panel and alt active or a selection also. So it's a configuration, but it's a little bit quick to go through everything like this. So this will be just a yeah, just so that you have seen how things works and so on. And again, if you want to learn more, follow this or go and check these sites here or guides, and then also contact us at Strusoft and we'll schedule a training with you. And then the last tab is the specifications, and the specifications are of course the information that comes up here. So it's for the element, but it's more for, you know, depending on the drawing. So what concrete grade we are using, what cement type and so on, and the strengths on in mold and or after 28 days, and when stripping the mold, we can put the default covers and so on, and these ones will then be connected to parameters. So in this example here, it was not connected, but it will look something like this in reality. So this is also the default ones. So remember that when we were in the properties, I'll show that quickly. Modify and properties. Remember that we had these specifications. So here we could also change from the default ones while we have it generated, the drawing, I mean. So that's it with the drawing templates. So we'll continue with the normal drawings, or not the normal, but the other drawings, let's say. So all the drawings that are not shop drawings. So I'll start with closing the template. I can save the project. It's always good to save when when that Revit reminds us to do it. But yeah, the drawings is pretty much all the other drawings. So normally it's the plan drawings, elevation drawings, but then it could be what we call other drawings. It could be 3D drawing, some specific drawing for some details or whatever. So how to create them? We'll take a look, and yeah, the functionality is placed here on the under the or second under create shop drawings, and it's called create drawings. So here we can filter this view. So if this list is very, very long, then we can filter out on like plan or level or whatever. But I want to create a plan drawing for level 1 and building 1. So that's my floor plan 1. Then what sheet to use? I want to use the A1, and if I want to have a prefix, that's fine. Then when we are selecting like either plan or elevation, then impact will notice here. So if I would have changed to, so this one will get an elevation, and if I do 3D, it will be other. So this is like to categorize the drawings in the database, and then later on in the project manager. So then you also get like this here. Yeah, if you have different floors, of course. So you need to configure what building, floor, and face the drawing is for. But now I'm in level 1, so everything is fine. The same needs to be done for the elevation. Then floor is probably a little bit tricky, so that one is not that necessary. But then the building and face is necessary. And for other drawings, all of these are grayed out. So if you're creating a 3D drawing, then you don't need to care about them. But this is what I'm gonna do. So I'll click OK, and we'll generate a drawing like this. And then, of course, this is just a preview of the drawing. So here we need to make some changes. So maybe turn off the title. Oh, sorry, this no title. Maybe we want to turn off these um, what they're called, elevation elevations. So we can go here in visibility graphics, either view visibility graphics or VV, and go down here to E, turn off the elevations so that they are removed. And then maybe I want to have this one in shaded, so I see the elements like this. And yeah, you can do a lot of changes, of course. And then when the content is there and you can add your own tables and so on, then the drawing works exactly as a shop drawing for revisions, for drawing properties, or for creating PDF drawings. So and when creating the PDF drawings, you will end up with elements under here. So 3D, or sorry, not 3D, floor plans, elevation, and other drawings. That are the three that we are using, and it's the same as we saw her floor plan, elevation, and other drawings. So next, we'll take a look at schedules and reports. So the schedules are Revit, and the reports are impact. So they're like different situations where you would use these two, and I have an example of each. So we'll take a look at that. So first, with the schedules, they can be used for when you model or create the elements, and you can also use them to print out a list or so. But let's say that we are creating a schedule for generic models. So we're gonna follow this guide and just see how we set this up in Revit. So we can close this one. And before we do that, I'll just show that all the drawings will end up here in the sheets. So if I close this one and click here, the drawing will pop up. So anyways, with the schedules, I'll go into view, and then we have the schedules, and then we have some different ones, but we are going to use the schedule quantities. So here you can either start with a multi-category, which is basically putting like all the different element types or family types. But the more specific you are, the more accurate content you will get as well. Also, like for specific family types or category types, there are specific functionalities. So just take the generic models and say okay, and we are going to create a list for the custom materials. So on the left side here, we have the available parameters, and on the right side, we have the parameters that we have in the list. So we are going to add like these here first, or we have 3 impact parameters and then 1 count. So we can start with the count because that's up here. So select it and then just add parameter, and then it will move to the right. And if I selected the wrong one or I changed my mind, I'll just select this one and use this remove to get it back there. Then we have on the impact, and we are adding the sim mark, so this one. We're also adding the sim description, sim schedule, or sorry, not sim schedule, but impact schedule. Impact schedule, that one, and impact map name, this one. So that's great. Then the order that we have here is also the order that we'll get in the table. So I want the sim mark to be first. So I select that one, and then we have move up and down arrows. Then count, then description, schedule, and map. That's fine. So these are the parameters I want to have in my schedule. Then in the next part, we have the filter. And in the filter, you can set up how what content to get, because we are selecting the generic models, and that's like a lot. It's all the recesses, it's all casting materials and so on. So here I only want to see the casting materials. So we have this impact schedule, and we'll filter on that. And then what to filter on, we have some different options. We want to have all generic models that have the impact schedule equals custom material. So here we have opening if we want to make a wall and door or a window and door schedule, or a strand schedule for pre-stressed elements, but I want to have that for custom materials. And I also want only the custom materials that are loose, let's say. So no custom materials for my MEP key that I added here in this element on the first floor. So then I can say the map name, and I'll say that, okay, I want to filter out all the generic models that have no value in this one. So has no value. So this means that if we have a generic model that have or that fulfill this first filter, but don't have a but have a map name, then we won't show it. And that's exactly what the aim is here. Then if we switch to the next tab, we have the sorting and grouping, and here we decide like how to order the content in the list. So we can say that we sort by custom material mark, and we do ascending, so from low numbers to high numbers. We can also uncheck this itemize every instance, because we have this count parameter. So if we have this one checked, then even if let's say that we have a custom material that's called 0191, the lifter that we created. So if we have 2 or 3 of them, so having itemize every instance will give us 3 individual rows of them. But we want to summarize the same custom material, so we get a list that is more shorter, and then we click this one. The next tab is formatting, and here we can decide a lot of different things. We can change the headlines of the parameters and so on. But we can also hide the field. So this impact schedule, I don't want to see the content of it. This one should only be there in the background to filter out what information I get. So this one won't be seen in the schedule, so then I click hidden field. And there are a lot of other settings here, but we'll just take the basics. And then we can click OK, and we'll generate a list of custom material. Also, what we could have done is change this one to also hide, because we use this one only for filtering purposes as well. So MEP and hide field or hidden field, then we'll get a better list here. So now we got the list of all the custom materials that we have in this project. And yeah, this one can be changed, of course, the name. So costs in materials, like that. So yeah, this can be used in a lot of different ways, of course. And yeah, you can do it for all things. So let's say that you want to have a list of all the walls, so that you see that they are sorted by length for some reason or whatever. But the same example here with custom materials, we can do something similar in impact. So we'll take a look at that as well. If we go to the icon that is above this update arrow, we go to the backstage menu, and then we can click on the reports. And here we have a lot of reports that are prepared. So basically lists that we can use to extract information from the database. So we are going to select the custom material summary. So this one here. And yeah, here we have a lot of filters if you want to filter out on specific building, floor, face, factory or division, if that's for the production, some product, or if we only want one type of cost material, for instance, or for a range of elements. But I'll just take everything here. So click print. And we are using Excel for this, so an Excel list will be generated, and it's done now. And here is something similar to what we got in Revit. So yeah, two different ways of doing the same thing basically. And as you can see here, there are a lot of different predefined templates for reports. So yeah, the one in Revit is something that you build up in the model, and these ones are prepared templates. So these ones are quicker and they can be standardized, while Revit can give you information that you can use yeah, more customized and flexible, but also that you can use them in the modeling here. This is more for yeah, for when the drawing is done and we want to send out and like buy cost materials, or send out like bending schedules for stirrups and so on. So we are actually in the end of the training. So this was the last thing we were going through. So we click here, and this is what we should have achieved. And if we go to the Revit, it's exactly what we have had created. So great job. We have gone through a lot of things. And yeah, that's we can also take a look at the drawing from or the model in Impact. So this is something that we can use yeah, to start producing with Impact Cast and so on. So I'll round off now. Again, thank you for attending this this training. If you have any questions, just contact any of the salespeople at Strusoft or the support team at Strusoft, and we will be more than happy to to answer your questions.